Check, check. Check.
Hi, how are you?
Doing well. My job went into the queue, so I'm waiting. I'll probably log in and check what happened. But most of the cases for RAP, it ran. It's over, I think so. So RAP cases are done, control cases.
Okay.
It's more about the complaint that I will start. Maybe a bunch of stupid questions.
Good morning. Good morning. Hello, everyone. Happy Friday. Thank you for being here in person and online, if there is anyone online. I'm Allison Gregory. I'm your MC for our last and final, most joyous day. And what are we doing today? So we are going to, first of all, I know you guys are dying to know, the raffle we are going to do after this first session. So that way, if you have a flight and you need to leave, you won't miss it. What else am I supposed to talk about? I'm doing time management today, but you guys know that. So get your raffle. And also the post-event survey was just sent out via email this morning, so do that when you get a chance. It's a little different than last year, and that feedback really helps us improve. So thank you for filling that out. And I don't know, my welcome is for 15 minutes, and I'm not sure what else I should welcome you guys about. Oh, look, there's me. Yeah, there's a thing for that. Yeah, we've had a great week. Thanks for coming to Boulder. I think if all of our community engagement collaboration people are here, which I don't know if they're virtual, if some of them are virtual and not here yet. Okay, because we might just start early then, if that's fine with everyone. So our chairs for the community engagement session, Jen Vaught, myself, and Tracy Finara. You want to come up? I don't know. You guys are chairing. What? Okay, well, so we're looking for Josh and Chandra and Brianna, Tracy and Edward. Okay. She's not here yet? She's not here yet, though, Kelvin is saying. So, because it's 9:03 and I was supposed to have a 15-minute welcome. Okay. Hendrik wants to sing for us. Okay, well, yeah, can the people in this session come up? I just didn't want to start without Brianna. Like, she can't. Okay. All right. Josh, do you want to come up here? Cool.
All right, hello everyone. My name is Joshua Kubelnik. I'm the Scrum Master on the Epic User Support team, and today I'm going to be talking about enabling community success through Epic User Support. So here's just an overview of what we're going over during this presentation. So an overview of Epic's resources and data management, the Epic Community Portal, documentation, tutorials, GitHub discussions, data management, and then QA as time allows. So first slide. Ooh. All right, so the first slide is the Epic Community Portal slide. So on the Epic Community Portal, we have 4 main sections: the Git code pages, the Git support pages, our brand new AI page, and our technical FAQs. The Git code page is a great way to get a broad overview of what a specific repository provides, and I'll talk more about that on the next slide. The AI page is a new addition to the portal. Here you can stay up to date with the latest Eagle AI efforts through blog posts. The AI page also showcases a landing page for NOAA's Project Eagle. The technical FAQs are a great place to find commonly asked technical questions for a given repository. So the Git support page is kind of a portal to all of our different features, including GitHub discussion forums, GitHub wikis, GitHub issues, and feature requests. So our Git code pages are all listed here. We have the UFS weather model, short-range weather application, the unified post-processor land data assimilation system, unified workflow tools, artificial intelligence, and then hierarchical system development, which is our newest page. And then the example here on the screen is for the UFS weather model. So you can see on the right-hand side of the screen, there's a nice blue navigation bar that provides easy access to resources such as documentation, developer information, useful links, and more. And then the main body will provide a description and additional resources such as links to version-specific information. So next is documentation and wikis. All of our supported repositories have a user's guide hosted on Read the Docs. And within this user's guide, you can find all sorts of information from tutorials to building and running to FAQs and more. Just a quick side note here, if you're switching between versions of the documentation, make sure that you are doing that from the home page to avoid 404 errors. And then each of our supported repositories also contains a GitHub wiki with even more information for users. And then next, I'm going to be talking a little bit about tutorials. So video tutorials are available under training resources on the Epic Community Portal. These tutorials provide a complete walkthrough and cover all necessary steps for users to achieve their goal. And then we also have text tutorials that are included within certain supported user guides. For example, the SRW User's Guide currently contains 3 tutorials. One of them is severe weather over Indianapolis case, where users can learn to change the physics suite and compare graphic plots. And then Halloween storm, where users can learn to change initial conditions and lateral boundary condition sources and compare results. And then we also have a choose your own adventure, where users can create a forecast of their choice on a custom grid using public available data. And just a side note, we're constantly adding new tutorials, so please check in for new information. And then next is GitHub discussions. So I linked to all of our repositories where users can post and ask a question. And we are required to reply to that within 48 hours. Oftentimes, it's same day. So please feel free to post your questions there, and we will either answer it ourselves or we will find the best person possible to answer it for you. And then also, if you're interested in any certain features or enhancements for Epic, please feel free to post in the UFS Community Enhancement category. And then each of our repositories also has a specific enhancement category, or you can email us at support.epic@noaa.gov. We also monitor that email daily. And then my last slide is data management. I am not the data manager, but I'll do the best I can. So the Epic data manager is responsible for all UFS data-related requests and maintaining the following S3 buckets. We have the SRW bucket, the weather model regression test bucket, the LandDA bucket, and the UFS coastal bucket. The data manager is also responsible for staging data for releases, for example, staging data on all Tier 1 platforms ahead of the SRW version 3 release. And for data request, you can use the data management homepage. And if you do not have access to that, feel free to email us at epic.support@noaa.gov. And that's all I have. Are there any questions?
Yeah, at least me. I'll
Okay,
give you a
yeah.
question. So I'm wondering, in the GitHub support, what's kind of the most common question that gets asked, or the most common theme that people need help with right now?
Possible to answer, just because all the questions we get are so technical and hyper specific. I can't really. They're just all so different. I don't know. There's not really a theme or one that's more commonly asked than the other. Yeah, Maui. Yeah, we do have an FAQ page which has all of our most commonly asked questions, but generally, the questions we get now that we have an established FAQ page are mostly pretty specific and technical, so it's not really a recurring theme.
I had a question about the, excuse me, about the SRW tutorials. You said that it includes all of the necessary steps. Does that include the full installation of the model?
Yes, we have documentation
So if
for
I-
building and running the models
so
as well.
if I started from just my Linux cluster and walked all the way through that, with nothing installed.
Yes,
Okay, great.
yeah.
That's good to hear.
Hello, good morning. My name is Chandra Kandagunta from the Weather Program Office. I'm also the JTTI Program Manager. I'm going to talk about the synergy between the JTTI and EPIC and advancing NOAA's Unified Forecast System. I would like to acknowledge my co-author, Maui Huang, who is from the Weather Program Office and also the EPIC Program Manager. Okay, so this is the outline. I'll briefly talk about the JTTI and EPIC missions. You already know EPIC mission, but I don't spend much time on it. And then I talk about the current NWS R202R cycle. And then I talk about the synergy between JTTI and EPIC and then finally talk about the success stories that came out of the synergy between these two programs. So this is about Joint Technology Transfer Initiative. It was created by U.S. Congress in FY16. And in FY17, it became part of the Weather Act, the 2017 Weather Act. If you are following the news, 2017 Weather Act is being reauthorized, and it is undergoing the legislative process. So JTTI is one of the main programs in the Weather Act reauthorization. So I'll just simply say that the main mission is to transition matured weather research from the American Weather Enterprise to the NWS operations. That's the mission of the JTTI. So this is the current JTTI project status. To date, JTTI funded 155 research to operations projects. Of those 155, it transitioned 29 projects to the operations. And these 29 include, okay, so this updated presentation didn't go through. I provided the updated presentation. Anyway, this still looks like still old one. Okay. So that includes the social science projects and the four, we actually transitioned 4 AIML projects and 2 projects from the private sector. Perhaps the JTTI is the first program to transition a private sector project to the NWS operations. Basically, JTTI paved the path to transition private sector and academic research into the operations. So what you also see here is from this pie diagram, 70% of the JTTA funded projects support EFS modeling activities. That's what I want you to make note of because that is relevant to this session. This is about EPIC. I think you have already seen this several times, so I don't say much about it other than saying that its mission is to enable the R2O2R cycle. Okay, so I'll spend some time on explaining this. This is the current R2O2R cycle of weather service. So I divided the whole gamut of weather forecasting process into 3 frameworks, namely the observational framework, modeling framework, and products and services. The JTTA funded activities are shown in purple color, and so JTTA funded activities are shown in purple color, and NWS activities are shown in the gray color. So as you can see, JTTA funded activities in all 3 frameworks. So for the purpose of this talk, let's focus on only the modeling framework. So what you see in the middle modeling framework is that the typical progression of a modeling an app follows these the 3 phases. Basically, there are mostly 2 phases: a development phase, testing and evaluation phase, and operational testing phase. So basically, these 3 phases constitute. They comprise of RL readiness levels 4 to 8. So basically, JTTI does not fund the research projects, nor does it fund the operational transition. So JTTI funds project and readiness levels 4 to 8. Let's take a look at the synergy between JTTI and EPIC. So what I did here was I took the same diagram before, and everything is same, except that we added actually a couple of new, this is not actually box, new activities to show the EPIC activities, the O2R activities. So, and also we added another box to reflect the latest activities of AIML model development and testing and evaluation, because that's what is happening lately. So what you see is if a project is deemed suitable for operational transition after testing and evaluation, then that project goes through operational testing and then gets implemented in the NWS operations. So this is the path JTTI funds. So what Epic can do is Epic can take the same application after being tested at testing and evaluation. It can take the same project and make the code changes and release to the public, and then public in turn can use that to do research and then close the R2O loops. Basically what you see here is the R2O here and O2R loop, basically the complete R2O O2R cycle here. But also what you see is in this the box where it is shown in the light yellow box, the activities shown in the light yellow box are common to both Epic and JTTI programs. Basically, this is where the synergy is. This is synergy between these two programs. Basically, these two programs have to work synergetically to advance the R2O to R cycle. So this is the crux of my presentation. Basically, all the activities shown in this box are funded by JTTI, and Epic can take advantage of these JTTI funded activities and release to the public, so the public can do the research and then close the R2O loops. So basically, Epic gets benefited from the JTTI funding in this box, and then Epic gets benefited from the Epic's building of Epic's infrastructure through this O2R loop, basically. So basically, this Epic and JTTR have to work synergistically to accelerate the O2R to R cycle. So these are the success stories. I won't go through all the details. Basically, there are 5 of them: UFS weather model, land DA, and SRW app, unified workflow. And this is again the old one. So what I had was the last was, we collaborated on a funding opportunity, but lately JTTI funded the integration of MPAS into UFS. So that's what I had there. So basically in all these activities, JTTI funded the development, testing and evaluation activities, and Epic funded the code changes, public release, and user support. So that's why these two programs work together in completing the O2R cycle. So that's what I have. Questions?
Well, actually, more like a kind of an addition. First of all, thank you, Chandra, for almost a decade of us working together on this kind of stuff. Really appreciate it. So two observations on this. And if you saw that cover of the report, Bridging the Valley of Death, there were 10 recommendations in there from the National Academy of Sciences of how to get the R2O process faster. We implemented every single one of them, and nothing went faster. And so this is really something that we're learning as we go with the community to go forward. And so the only place where we actually have been able to see things going faster is with an UFS style approach, where instead of you doing research, then you wait a long time, it goes into operations, and this is already really old. The thing that Chandra and the JTTI program really need to get acknowledged for is that when we started this project, it was really hard to figure out what to fund that would actually go to operations. And we estimated that when I started working with him on that there's only 30% of the first year JTTI funding was on projects that had a chance to go into operations. The last few years, that has been pretty much 100%. And so the fact that we're doing a UFS is a step further from what we did with the recommendations in that report. But the fact that the JTTI is really focusing on making sure that they provide funds for the people that really have a chance to go into operations, that is a achievement that deserves more kudos than they usually get. Thank you.
Yeah, thank you.
I want to echo what Hendrik just said. Many of you might not have realized that JTTI program is actually the program that initiated the whole UFS business. So his last slide stated that UFS weather model actually started from JTTI funding. Back in 2019, EPIC didn't exist. So Danae Carlos, the inaugural EPIC program manager, actually borrowed funding from JTTI to initiate that effort. So I cannot thank John Jeff more.
Thank you, Mavi. If I say that, it would look like I'm bragging, but thank you for the comment.
All right, next we have my former close colleague, Brianna Vanderplow, and she's going to be talking about something super exciting, Cloud Sandbox. So take it away, Brianna. I think you can share your slide, share your screen.
Yeah, can you guys hear me?
Yes, it's a little low. You might want to come a little closer.
Is that better?
Give us a 1, 2, 3.
1, 2, 3.
There you go. Yep, that was good. All
I'll
right.
just try to. All right. Hi, everybody. Thanks, Tracy. So my name's Brianna Vanderplow. I am a contractor for the U.S. Integrated Ocean Observing System Office. It's a part of the National Ocean Service. And like Tracy said, we're talking about something cool and exciting, which is a project we're working on to advance community ocean and coastal modeling by harnessing the power of the cloud. So this was also done in collaboration with Linker and Tetra Tech RPS, two of our industry partners. So I'm going to start with kind of motivation, and the last talk was a really good intro to some of the motivation behind this project as well, of improving the research to operations pipeline and pathway, because that is a challenge. So that is also motivation behind this project. But a lot of people are probably familiar with the architecture of a traditional high performance computer. So that's just showing that schematic here. But really the focus I want to talk about are these limitations that are associated with it. And those are high initial costs, limited collaboration opportunities, especially when you're within the NOAA infrastructure, long job queues that you probably have to wait in. And then once you get through those, you have limited run times. Maybe it's 8 hours, whatever that time window might be. There's limited resources and configurations. And then you or maybe your IT support have to deal with maintenance and failures if it's an on-site HPC. And then there is time-consuming data access and data transfer if you're uploading and downloading data to local machines. And so considering that, the IU's office has developed the NOS Coastal Modeling Cloud Sandbox. So this schematic here is just showing a cool visual of the dream of what this project is. And it is basically a service, a platform where private industry, research and academia, external partners can work with internal NOAA partners to co-develop these models in the same space. And that could really help to improve this research to operations pipeline so that there isn't that back and forth and transfer and delay in working on developing these models. So the big point here is that it is a community development platform that can bring all of these different partners together. And so something we've run into as we've been soliciting this project and starting to get users on has been, why should I use the sandbox instead of my own computer? And so we've really worked on highlighting and honing in on what are some of these benefits, and most of them associate with that this platform overcomes those limitations I went over in the first slide. So with the sandbox, and this is an Amazon Web Services hosted cloud platform, but there is immediate job execution. You don't have to wait in line to run your model. You can run without time limits. Basically, your model will run until it fails and has an issue or it completes. AWS is really scalable and flexible, and they have a ton of instance inventory and different configurations that you can develop to run your model. You can run benchmark testing to figure out what the optimal configuration is. There are enhanced analysis tools. So we have AWS SageMaker, which is like a Jupyter Hub platform, and we're working on getting Nabari on the sandbox as well. There is improved data access. So if you're in the cloud, you can pull data from other cloud sources, from S3 on Amazon. You can pull that data into the sandbox, pre-process it for your model, run your model, and then look at your model results and share data all in the same space. So that speeds things up as well. And then the last one is really the collaborative development, which was the main motivation behind this work. And that is a huge, huge benefit to it. And so I want to go over one of the other things that we've come across as we've been bringing users on, and that has been that having people, once they're on board and they're like, all right, I see the benefits, let's move forward, it's adapting their model workflow to come onto the cloud. And so that has been a bit of a challenge. They're maybe not familiar with that. It is a little bit different than your traditional model workflow. And so we've had the help from our developers at Linker and RPS to facilitate that. And they have to figure out their instance type and availability and what works best, and maybe that benchmark testing and various other things in the cloud. But so we have learned from a couple of these models here that we really need to focus on onboarding and documentation during the engagement process, and making sure that they have that really well laid out of how that process will work and have support is one of the lessons learned so far there. So a couple of the models that have run in the sandbox, we have an external model from the University of Washington, Live Ocean, in the Pacific Northwest, the coastal ocean reanalysis from co-ops, as well as the national water models running a reanalysis from the Office of Water Prediction, and then from the Office of Coast Survey, the STOFS 2D Global has run some model runs in the sandbox as well. So big challenge that we have faced, and it's very ironic because, as I've already mentioned, the big benefit and motivation of this project was this is a community development platform where NOAA modelers and partner modelers can be in the same space. Well, that has been the big driving factor. That has also been our biggest challenge in this project. And so getting external partners onto NOAA resources without a CAC has been a huge process, getting the approvals, and then getting, once we finally got a solution approved, which is Okta, we now are working through actually implementing that and getting it to work. And so it has been a very big challenge, and we've learned to be persistent. We really see the value in this and what this project could be. So we've stayed persistent, and we are very close to getting it implemented and working. So basically, that original graph I showed, the partner access is blocked by this firewall, but we have the solution of Okta, which should make it really easy to have users authenticate and log into the NOAA resources without having to apply for a CAC and wait for 6 months to a year and whatever going through that process. So but moving forward with that, once this is implemented and going back to that big goal of this project, to have community development in one space from external and internal modelers, and improving the research to operations pipeline. We have 3 models that are currently, while we're awaiting that external access, being tested and compiled in the sandbox so that they're ready for when these partners can come on. We have 3 models along the East Coast that are being tested right now. And that is an East Coast Community Ocean Forecast System, the Northeast Coastal Ocean Forecast System, and the Southeast Coastal Ocean Forecast System. So there's a larger domain of the full East Coast that covers the Caribbean, the Gulf, and then the whole Atlantic we can see here. And then these 2 other models are smaller, higher resolution regional models that will be coupled with the national water model. But all of these are in the process and being slated for operations at NOAA. So they're working with OCS and co-ops. And they will hopefully all be together in the same space, being able to co-develop and work on that code. And this will also give us a lot more coverage at the operational level along the entire East Coast and fill some of these gaps. So the sandbox hopefully will be able to play a role in speeding up this process and making it more efficient and effective. So just to leave you with a couple of the take homes that I already touched on and what we see as our path to success with this project is to simplify this collaboration and the bigger goal via the external user access. We've learned that really offering that training and documentation and onboarding is really, really critical, as well as continuous engagement, keeping people interested, being there for support and helping them, and just always reaching out is really critical as well. And then remaining persistent and flexible when roadblocks occur. We've had big ones, we've had small ones, but just staying focused on the bigger goals and being flexible has been a really big lesson learned. So if you want to know more, I have our general contact email here. We also have a GitHub, and we have a website that you can scan the QR code there if you want to check out more. Thank you.
Hi, Brianna. I do have a question. I actually work on the Epic platform team, and we're kind of in the same position as you are with trying to actually have an AWS-based sandbox account and offering collaboration to users, but we're kind of running into some of the same problems. Can you speak a little bit more about security and access controls? You mentioned Okta, but can you expound on that a little bit? Because I'd really love to understand how you're controlling user access into the environment, but still keeping it safe and keeping it within, I would say, some of the security boundaries.
Yeah, I can touch on it. I will say I don't know all the nitty-gritty details about it. And that has been part of the issue, right? Of like you're saying, that's the challenges you're facing. That is why it has been so hard, because we've looked at different options in the past and they were not approved because they weren't secure enough. So NOAA, the OCIO office, agreed that Okta is secure and that Okta will allow that. And they have to go through that process and register through that platform and have the multi-factor authentication. And we have to give that okay, and they have to track which users are going to be approved. And so we're working on, like, that has not fully been implemented, and that's part of the process of we got this approval. They said this is the okay method. Now it's figuring out all those details of how do we keep this compliant with all of that. So that is all still in progress, but yeah, that's a huge challenge. But we're just working really closely with the OCIO office to make sure we're doing all of that correctly. And it's just taking a lot longer than we had originally hoped to make sure we're doing it right.
Okay, thank you.
Yeah, thank you.
Yeah, Brianna, thanks for the presentation. Just a quick question. Is the sandbox vulnerable if any of the government IT contracts or with AWS don't get renewed? Is that a vulnerability for you at all?
So on the larger scale, I know we have, so at our contract with AWS, I don't believe falls into like a larger one on the NOAA scale. We have an individual one that we've been working with them. But obviously if generally we run into another issue with contracts being approved, that would influence how much compute there is available on AWS, of course. And the same with, we have industry partners that are contracts that are the development side of this. So we already ran into this year getting one of those approved, and we did have to work really hard to get that. And there was a lapse, as many other offices also experienced. So hopefully we all don't run into that again, but that obviously is a consideration and something that we have our eyes on as risk, of course.
Beautiful presentation. I love seeing this. This is the same ideas that we have at the UFS in general. If you can get your people to your computer, you'll bring your software to the people, and that's very nicely. Quick thing that I kind of missed in your presentation. So who pays for the cloud in your sandbox?
So yeah, right now we are funding the compute. And so that is a really big incentive that we have tried to offer to people. And a lot of the internal NOAA partners that have run their models, like the Stoffs 2D and Cora, that has been a really big benefit to them, is that we are covering the compute right now. Like that is completely funded
So
to get people on this platform.
Yeah, so if you're getting popular with your platform, then that is going to be a constrained resource too, right?
Absolutely. So in thinking about that towards the future, it has not become an issue yet, but thinking about that, we have started to look at how do we develop a dashboard that users could come in and estimate what their compute costs might be, once we're not covering that, and see if it would be beneficial for them to use this platform. So we're trying to develop something that in the long term that users could come in and be able to know if this would decrease costs or how that would work if it would make their workflow more efficient.
So as a follow-up on that, and then John can go. Have you made a dollar cost comparison? What it costs in real dollars on the cloud compared to running something similar on like WCOS or other owned hardware?
So that is in the plan to document and make sure we have good, basically documentation of that and showing both the time efficiency and, cost comparisons. So it has not been completed yet, but it's in our milestones.
I love to see that because the claims on that are all over the map. So if you have some hard data, I'd love to see that. Thank you.
All right, very, very quick question. You're getting a lot of these questions because you're helping solve a problem that we've had for a while in Epic. But are you working with OCIO or are you working with ACIO for Ocean Service?
OCIO. Maybe we're working with
NOAA OCIO.
I definitely most of the time we're working with OCIO. Yeah.
NOAA OCIO. Okay, that was it. Okay, thanks.
Thank you, Brianna. I also just wanted to add that if you liked her presentation, she did Tracy and I's communicating science training that we hosted before the workshop to help you prepare for your presentation. So if you want to do that next year, we will probably also host that next year. So it's a great opportunity. Okay, Tracy, you ready?
All right, good morning, everyone. I'm Tracy Hartnicki with NSF-NCAR and the Developmental Testbed Center, and I'll be talking to you about the Common Community Physics Package. First, I want to acknowledge the whole CCPP team that's listed here on the slide. All right. So when the CCPP was first being conceptualized, there was a desire to create an infrastructure that would, one, facilitate the development of physics parameterizations, enable their testing across different atmospheric models, as well as accelerate transitions of innovations into operational models. The physics schemes did need to be interoperable across multiple dynamical cores, and that would just lower the barriers of scientific exchange. And then there also needed to be well-established community support and developmental practices for the CCPP. So the CCPP is composed of two main components. The first is a consolidated library of physics parameterizations usable in both operations and for research interests, and those are all suitable for all UFS applications. And then the second one is a framework for connecting the physics parameterizations with a host application. So the schematic here kind of illustrates how those components fit into the whole picture, for example, into the UFS. And so you have on top the atmospheric driver. This is basically your main calling program. It's in charge of time step integration and maintaining the model state and so on. And then you also have the CCPP physics in the bottom of the schematic, and those are basically all your physics schemes and suites that are available in the CCPP physics code repository. And so for each scheme in the repository, there's also a metadata table that is included, and that lists all of the variables and requirements that are needed for the scheme in order for them to function properly. And then similarly, within the atmospheric or the host model, there's also metadata table that lists all of the variables that it can provide and where to find them. And so at build time, the CCPP framework will collect the metadata from the host model and the physics and auto-generate these physics caps or physics drivers for running the model. All right, this is the list of supported suites in the current public release version 7 of CCPP. They include both operational and developmental suites. One thing I just want to note is the names of these suites are somewhat arbitrary, and if you want to have some code reproducibility, you might want to check out the specific tags or releases in order to get a snapshot of the code that you want to be reproducible. So this table is more of a reference of what's included in those physics suites. All right, CCPP is being widely implemented. For UFS operational implementations, it's already in the HAVS model, as well as the AQM version 7 model. And then it's also slated for implementation into the GFS, the GEFS, the RRFS, and the SFS models. And then there's some other non-NOAA implementations that include the Naval Research Laboratories Neptune, as well as NSF/NCAR's CAM-SEMA. All right, so also bundled with the CCPP is the CCPP single column model. Single column model is a basic model that denies interactions because there is no dynamical core, and instead you prescribe forcing data to drive the model. So the purpose of including a CCPP single column model is to provide the most simple example for connecting the CCPP physics to a host model. It also allows efficient testing of physics at the physical process level as part of the HSD framework. And while the single column model is definitely a very useful and necessary tool in the HSD framework, I just want to make one note that it is not a sufficient standalone tool, and it should be complementing other testing within the whole model hierarchy. All right, so the latest release of the single column model is version 7.0.1. It was released earlier this summer, and it's bundled with the version 7 of CCPP, and it includes some minor enhancements and bug fixes, and generally a lot of those things come from the community. So we learn about these things that the community wants or that they find that need to be fixed, and then so we can release these minor releases. All right, so the single column model can be run a number of ways. Within the repository, there is forcing data sets that span a range of broad weather regimes and applications that can be used in to run the single column model. It's also compatible with the DEFI format forcing files, and that is an international standard for single column model forcing. There is an external repository for the DEFI format that has a number of cases. I'll just make one note that there are a couple cases within that repository that have forcing mechanisms that aren't currently supported in the CCPP for the single column model. And so just keep that in mind when you're running cases from that repository, because we don't technically support it. And then the last way to run the single column model is there's a capability to generate cases from UFS forcing files, such as the SRW output and so on. The single column model also does support single precision. All right, this is a list of the CCPP components and their links on GitHub. And if you go to the GitHub links, you can also find documentation and user's guides for the various components. And we do provide support via GitHub discussions and issues. And also, if you're like a model developer that wants to get your physics into the CCPP, we encourage you to open a discussion or an issue with us to get that conversation started. You can also contribute cases to the single column model as well. And so, yeah, we just have that, the discussions and issue tracking for the community support. And with that, I will say thank you. And if there's any questions, I'll take them now.
Great talk and overview, Tracy. Thank you very much. For some of us of a certain age, it was a habit of just saying CCCP, but that's the old Soviet Union days. So you did mention the HSD, hierarchical system development, and how that's supported, by the SCM. Did you want to comment further about how CCPP helps the rest of the hierarchical system development?
Yeah, so the CCPP is definitely a component in all of the different hierarchical model levels. So all the way from the most simple processes like the single column model to the the SRW, as well as fully coupled models. So yeah.
I'm Fanny Yang from NCPMC. Tracy, you mentioned the single column model version supports single precision. Is that does it work for all the physics options? First question. Second question, do we need any more test evaluation in the 3D model, or we can start to use a single precision option?
To my knowledge, it's not available for all of the physics, but I don't know enough about it to say which ones it is available for. I don't see any of the team here to comment on that either, so.
I can catch up with them offline.
Hi, I have one question. So, is this single column model different than CM1? And the other question is it computationally more efficient than the CM1?
I'm not really familiar with running the CM1. It is very efficient, but I can't answer that question because I don't know much about the CM1. I'm sorry.
Really quick technical question, since I'm a NOAA guy and you're from UCAR NCAR. Is the CCPP also completely being integrated in MPAS these days? Or?
Yeah, there is work going on to integrate the MPAS DICOR into the CCPP, and I know that work is ongoing. There's also work in a separate project that I'm not involved with, so I don't have a lot of information about getting MPAS physics into CCPP as well.
Okay, can I ask another? Or, okay, so as a wave modeler, I do something very similar with the fact that we basically look at all our physics locally. As part of looking at software modernization in general, we find that if you structure your model like that, that the code is not particularly well structured to be optimized on GPUs. Has there been any looking at whether or not this columns model has to be solved over a block of grid points rather than a single grid point and things like that, in terms of being able to have architecture that is more suitable for GPUs?
There has been conversation about GPUizing the CCPP. We haven't really started that process yet, but yeah, it's certainly something that we're starting to look at and think about.
I think you're just as far as most of us with that, the fact that we recognize that we have to look at it.
Yeah.
Thanks.
Yeah.
Good morning, everyone. My name is Eddie Snyder. I work for Raytheon. I work on the NOAA EPIC program. And my presentation is called Rethinking SPAC Support a Containerized Approach. So the outline, we'll briefly talk about what SPAC is, talk about the current level of support, as well as like EPIC's, I guess, trouble with that support, and then some solutions that we looked into, and then a transition plan / our current work. So what is SPAC? It's a Python-based package manager forked off SPAC, initially developed by Joint Center for Satellite Data Assimilation. It is currently being supported by JCSDA, NOAA EPIC, and NOAA EMC, and the U.S. Naval Research Laboratory. SPAC is essentially like the underlying code base you need to build your UFS weather model or Jedi model or application. So it's very crucial to the UFS weather model. Current spec stack support is split between all the organizations I mentioned in the previous slide. Recently, Epic has onboarded, I guess, too many, tier 1 platforms, and our developers are sort of operating at a maintenance level instead of coming up with development work. So to free up our developer time to focus on, development tasks and reduce platform support, we looked into 2 ways to build spec stack environments. First one would be automating, and the next one is containerization. So for automating, we looked into Jenkins to build spec stack environments. It's a really nice option if you can get it to build successfully the first time. If not, you have to go back and troubleshoot it. But there are some drawbacks. It does cost some money. There's some initial learning of Jenkins software, but that's not hard to learn. And then again, we're still building spec stack on all the other supported platforms. The next thing we briefly looked into is leveraging spec binary cache or mirrors. This does speed up the build time from hours to minutes, which is really nice. However, we will have to figure out how to do a centralized spec cache location and to support that as well. And again, we still have to build spec stack on various tier 1 platforms. So we looked into containerizing spec stack. Containerizing spec stack essentially contains your Intel compilers, spec stack, and container scripts. Container scripts are a set of scripts that sync your container to the platform you're on, as well as sync your model or application to run in the container. So it works in that the build tools, so your CMake and make, are essentially wrapper scripts. So when they're called on your system, they'll run in the container, so your application will be built in the container. Likewise, there's executables. Your executables will be wrappers as well. Will then also run in the container. So it's a really nice way to build or to use spec stack. So how's the container being built? Does it show up? Oh, very cool. Nice. So this is a Docker file. It contains your Intel Docker image that has the Intel compilers. We then add spec stack to it, and then the container scripts as well. Once the Docker file is built, it becomes a Docker image, and then from there we can use some Singularity commands to create a Singularity image file or SIF. We'll just call it container because it's easier that way, so that's how you build the spec stack container. In theory, if we build spec stack and container on one platform, it should work on the other platforms. I should also mention that Mark Potts demonstrated this container a couple months ago, and this is the same method that we're gonna try to move forward with. And he's tested on multiple platforms. I also has tested it on multiple platforms as well. So that's all pretty good, right? Unfortunately, we have some drawbacks. The first one was we discovered that there's an Intel end user license agreement. Turns out Intel does not like people distributing their intellectual property publicly. So we turned to NOAA General Counsel, Raytheon lawyers to figure out what we can do with that. Turns out if we have a NOAA employee download the Intel Docker image initially, then that container can be distributed or used to build the spec stack container, then that container can be distributed internally within NOAA. And then that does apply to NOAA affiliated employees as well as contractors. So we do have a drawback though, is the risk of non-NOAA affiliated users running it, and also developer training. We will have to do another demonstration similar to what Mark did a couple months ago. However, the feedback from that presentation was pretty positive, and we actually had a number of teams build their application using spec stack containers. So I don't think it's too difficult to learn, but that is just another thing we would have to look into. So where do we stand right now? The Epic container team, or I guess Epic team, came up with the container mitigation and migration plan. We submitted it to our leadership team as well as our stakeholders, which is EMC, for feedback and review. If everything is all kosher, then we'll move forward with the plan, which consists of how to use containers that comply with Intel's ULA, have a mitigation plan, which is essentially us hiding our GitHub repository and our Docker Hub repository so it's not publicly facing. Rebuild our application containers. Epic has done a number of application releases in the past that contain compilers. So we'll go back and rebuild those containers without compilers. And lastly, we have the migration plan itself, which is we will take the SPACstack container, put it on Ursa, and build the UFS weather model, LandDA, SRW, and any other various apps that run there. Make sure that the applications run and as well as the tests pass as well. So once everything looks good on Ursa, we'll move on to the next NOAA RDHPC Tier 1 platform. Once we go through that whole list, then we'll look at the non-NOAA RDHPC platforms, which for Epic, that is MSU and UCAR, which is Derecho, Hercules, and Orion platforms. We do need to talk to those sysadmins of how to figure out how to handle the containers on those platforms. We might natively build SPACstack there as well, because I've talked to a few people here that use the applications or use SPACstack on those platforms, but they're technically not NOAA affiliated employees. So we still have stuff, I guess, to look into regarding that. But that is the end of my talk. Does anyone have any questions? That is also generative AI. That is not, I've never seen a lightning strike like that. So, okay.
Thank you. I have one technical question. So, for example, you have a container you created, and then let's assume that I just want to upgrade one of the libraries to test something. Is it easy to do it, or it requires some deep knowledge related with the containers or something like that?
Probably you have to rebuild the whole stack, unfortunately.
So are you also providing those Docker files to the users that they can use as a reference and then change one of the libraries and then?
I mean, we should, but because of the Intel ULA, we probably shouldn't have the Docker file publicly available. We could, I guess, technically have it available, but yeah. See, this is the trouble that we have because we need to comply with Intel's end user license agreement. But
maybe just GCC works, so you don't need to.
I agree. Yeah, but I was told that the NOAA community generally uses Intel, so then we stuck with Intel. But no, I agree. Like GCC could work as well.
Because that brings extra flexibility to user side because they want to test something about the. And another minor question: I am generally using the SPACstack, the existing environment, and I am extending it with additional libraries.
Okay.
So how this would be in terms of if we go with the Docker container? Because we will have a base Docker container. Is it possible to use that base Docker container to extend it with the additional libraries?
I would think so. I mean, I have built. I have a SPAC add-on environment Docker file that I've used to modify different versions of like the base, if you want to call it like the base SPACstack. So it can be done. I think the presentation is more about like Epic support for SPACstack. Obviously, you can still build SPACstack yourself and go that route, but SPACstack's difficult to build. Not many people like to do it, so we're trying to make it easier. I think that's what Epic's role is, right? To make it easier for y'all to do the science. So we have. I guess we have two approaches, right? Like Epic's going to have the containers, but you can still build SPACstack yourself. So I don't know. Hopefully that answers your question.
Yeah, that's fine.
Okay.
Thank you, Mark.
Thank you.
Hi, Ed.
Yep.
My question, and I may have missed it in your presentation, are you using containers to emulate the Tier 1 platform so that you can build the SPACstack within the container and then install it natively?
Yeah, I didn't go into the details. So what we're doing is we're building SPACstack in the container, and then we're going to copy out like module files from the Docker from the container, and then there's some like the container scripts does some sort of magic, if you will, that syncs up that create wrapper scripts for the build tools. So yeah, we're not copying out, we're only copying out like the module file so that it will run in the container. I don't know if that.
No, I'm asking if you would use that to actually install the software natively on the system. So
No.
so that those who choose to run natively and not within the container will at least have the software, because it will greatly enhance your ability to build SpackStack for all of the platforms, to do it within containers and then install it natively.
Oh, really? Okay.
That's what we do at GFDL.
Okay, we should, yeah, I think we might have talked before. Yeah.
So I have a question
Sure.
As a member of the academic community.
Yeah.
So I'm not a NOAA affiliate, even though I'm here a lot. And I don't currently have access to the Tier 1 platforms. So from what you're describing, it seems like my only option would be to build SpackStack natively, that the container option is off the table for the academic community.
So the method I described, yes, but there is a way. We have other solutions that we should look into because Epic is broader than like NOAA affiliated employees, right? I believe there is a way we can make it work. Syncing up, like getting the Intel Docker image, make that a container, and maybe sync it up with the container that we have. There is a way. I haven't done it, but Mark and I have talked about it before. So.
Okay, because no one or no appreciable percentage of the community is going to build SpackStack on their own platforms.
Yeah.
No one in their right mind would do this, and I say this as someone who did. As soon as you make the research faculty spend hours firefighting SpackStack on their cluster, they will give up.
Yeah.
So far, containers have been the only viable path forward around that problem. So it's deeply disconcerting that we might lose that as an option. So I sincerely hope that whatever other solution you just described is viable, because otherwise we will not have a community model.
So the queue is not completely full, so I get a chance to ask another question. So for the record, a lot of us don't use Intel as Fortran. Specifically.
Well, then why did I do it?
we do use Intel once you're on the operational side, but I do a lot of my development, if I do it, and I'm going to back in that a little bit, I do a lot of that on whatever platform I'm finding, and I usually use GFortran as a portable compiler everywhere. And so, question one is there any idea, any plan to see if you can compile a spec stack using community compilers so you don't have this IP issue?
Yeah, that might be a better approach, just because of what the question before, right? Academia. If we have like one container that can be distributed to like your personal computer, that's great. That I don't know if it's in our task order or something to do it, but that's something we should consider. And if not, we can add it if that is I guess a big demand from the community. So yeah.
And I mean, it's a little bit different than container work, but as a point of reference, WaveWatch has always been distributed with compile options set for various compilers, so people could use choose if they use GFortran or Intel or whatever they had access to, and that helped enormously with the portability of the code and making sure that only people in their right mind would try to compile the code. So, just another observation from what you're saying right now. When I was talking a little bit earlier this week about different languages, I believe pretty much everything on the spec stack is still Fortran.
Yeah.
And so this is also an argument perhaps for looking at other languages other than the arguments I had for slowly moving away from Fortran. The simple fact that Python, C++, Julia, and Rust are all community software without licenses behind them, which makes it easier to port these kind of things without having to deal with backdoor legal issues.
Okay, thank you.
Just an observation.
I appreciate it, yeah.
Let me just comment, the SPAC stack is mostly Python-based, so it's
Okay.
not Fortran. No, by no means.
Okay, thank you.
S code may have underlying Fortran, but yeah, SPAC stack.
Yeah,
is
that's what I thought he meant. No, it is Python.
As a someone new to the UFS community, I shared the same question as he did. Is there a provision to maybe expand the resources, the tier 1 resources, like spec stack resources, to maybe Azure Cloud HPC or NSF Access, HPC resources that are accessible, or maybe provisions for providing the MSU HPC resources to interested students such as myself, so that maybe I can get a hand start on UFS. There are many others like me who want to work on the system.
Right.
But it does sound a bit exclusive.
Yeah, that's, yeah, I don't, Maui, are you gonna try and chime in, or? Yeah, I don't know the answer, so.
Yeah, so I want to clarify a few things. The whole point of what Eddie is for Eddie to develop this container is actually for us to be able to distribute UFS, weather model, and applications broadly to the academic community. So we actually, at least I have announced to some of our NOAA colleagues that once we get the container built, we are going to revise the definition of the tier 1 platforms. Realistically, we only need a research container and an operational container. And that research container should be portable to any academic machines. And I also see in this room, Eddie, just to note it to you, we have our GFDL colleagues and our NCAR colleagues. They are also supporting part of this community. We should build this container together. So once we get there, yes, the answer is firm, and yes, that's the goal. We want to make the use of UFS as easy as possible to all.
So if I want to get started on this right away after finishing the training, will there be provisions to get access to such resources for interested students, for just a demonstration? Because configuring these things might take quite a bit of time, and for non-NOAA users having limited resources, finding out what to configure and what's been published and what's been updated is a bit of a research in itself, I guess.
That's true. So we do have SPACstack currently built on MSU. If you have access to that directory, then you can use that SPACstack there. It's still natively built. We're not gonna remove that anytime soon. The container SPACstack approach is something that we're looking into because we just want to have more time to work on other tasks. And we still need to figure out how we're going to address the MSU, the academic side of it, because the current setup of the container is not, doesn't jive with the ULA, so we need to figure out a way around that. So.
I was just going to say the same thing. We should maybe start first with the MSU, see if we can even get the container built there, and then work a little bit more with Intel to see what's in the art of the possible. I think that's something that we can take on, but it's a challenge that we have right now.
Or maybe Azure clouds as well, because it's
Oh, Chris.
Sorry, if I could chime in. We do have. You actually attended one of our workshops. We've actually built SPACstack using HashiCorp Packer for a public cloud access. Now that could be ported over to, say, Amazon Web Services. So this is something where we can provide you your configuration, and this, of course, wouldn't violate the end-user licensing agreement because you're using the compiler, of course, it's provided there on the public cloud, and that could be a quick start solution to help students who want to, take that. And I think I actually kind of provided you with that configuration. I'm happy to kind of chat offline about that. But yeah, that option is available through Packer.
And I'll point out the EULA from Intel only applies to compiling. The runtime environment is free to use, free to distribute. So if all you need is an application that is already compiled and ready to run, it's not a problem. The container can be delivered to you as is with the runtime environment, the compiled version of whatever it is you want, and then you can run it anywhere you need to. It's only when you need to compile something that the EULA comes into effect. And it's easy, and one of the things that we will be working with the EPIC team on from GFDL is helping them to get a definition file so that you can go to Intel, download their container, and then from there, using the cache, using what we were talking about, having all of the SPAC stuff already in a container, you can then just copy that stuff into the compile container, compile it yourself, and then you can go forward. We can't distribute it to you, but you're free to download that container from Intel and do what you need to. So the goal is to provide you something in the end that will be a definition file that you can use to build the container.
Yes, thank you very much. I already have the configuration, so thank you.
Nice. Go.
All right, thank you to all of our presenters for this talk and for all of you guys for participating in this. This is I believe the first year we had this collaboration session, and I thought it was really productive, and I'm excited about it, and I feel like maybe we should have it earlier on in the week next year so that we can continue these conversations throughout the week instead of at the end. So that is just my brainstorming. So thank you for being patient. Now we are going to do the last raffle. Thank you, guys. And then we have a break, a 30-minute break. I think there's snacks out there. Okay. 082. 503082. It's John. All right, break.
That was easy.
2-minute warning, 2 minutes. All right, hope everyone had a lovely little sugar coffee break. Next, we are going to talk about the UFS Coastal Code Development Applications and Use Cases, and our chair is Saeed Mogimi. Know who's coming? Yes. Yes. Okay.
So, good morning, everybody. In this session, we are going to touch on two different topics. The first topic is about UFS Coastal Codebase, its development, and Dr. Ufuk Turkunklu are going to talk about some of the good lessons and some of the challenges that we have in this way. And right after Ufuk, Mansur Jisan, Dr. Jisan, going to talk about a little bit more deep dive on the UFS workflow that we are developing. This is a National Ocean Services workflow. We are trying to unify all of our operational workflow in one modernized Python code base. So from here, I just let maybe Ufuk to take the podium and start his presentation.
Oops. Thank you. I would like to talk a little bit about the existing coastal modeling framework that we are trying to develop, and I will talk a little bit more about our challenges that we faced at this point. Okay. Go back. Okay. So UFS Coastal is basically a fork of UFS Weather Model. Nothing changing there. So we are trying to sync with the UFS Weather Model as frequent as possible, every 2 months or something like that, because it's too much work for us to continue syncing with the UFS Weather Model every PR. Because it's evolving too fast, and then we decide to go with 1 or 2 months intervals. So we are trying to sync with the UFS Weather Model, so we want to be ready if they want to push any development from the UFS Coastal to UFS Weather Model. We have additional components, probably you already saw those. We have some coastal-specific ocean models, unstructured, ROMS is structured, but still applicable for the coastal work. And then we create this code base. We are using the existing infrastructure, existing regression testing system, additional components and creating additional applications and configurations. So at this point, the idea is to keep the change minimal. We have minor change in the CMAP side, the mediator, because we need a different coupling mode. We have additional data mode called ATM mesh, but I think we can get rid of that one, and then we can create some kinds of a generic data model. So CDEP's infrastructure can be also improved to allow more flexible approach. We have some additional change in the Wavewash 3 side, not too much. One of them is the UFS Coastal team wants to support the standalone Wavewash 3 runs under UFS Coastal framework. So we have minor modification related with that one. And then a minor modification in the build system. That's not too much. And then we will bring some more modification to CIs because we want to support the regional CIs coupling, especially in the Bering Sea and the Arctic Ocean. So because of that, we have 2 different PR to support the regional application for the CIs. Probably after this meeting, I will look at those and then we will merge them. But maybe after that, we need to push those development to authoritative repository, maybe CI's consortium or something like that. Because we don't want to diverge too much. We have, as I told you before, we are still using the existing regression testing system. We have a couple of extra regression testing system we are trying to support each model component that we have extra in the UFS Coastal with at least one regression test. So we have a set of regression tests. A couple of them is not too realistic, and it makes our life harder because we can't catch the issues with those regression tests. And then we are trying to switch to more realistic configuration using the DAC North Carolina case. So the aim is to, for example, let's assume that we are syncing with the UFS weather model. Once we sync it, we need to pass all those regression tests. Of course, we have issues, and then we are trying to solve them, and then we are going with that way. So the main philosophy behind of maintaining UFS Coastal is actually simple. Don't diverge, rule 1. Rule 2, careful testing, because, for example, let's assume that we are developing something in the UFS Coastal side, as an example of CIs, but we don't want to break anything in the UFS weather model. So we are also running some set of UFS weather model regression tests to check our development and be sure that we are not breaking anything in the UFS weather model. Rule 3 is isolate changes. So for example, if we need some particular feature from a particular component, we are trying to isolate that one. So maybe it could be runtime configurable option, or it could be CPP option or something like that. So if we isolate that change, it will be much more easier for us to push that change to the authoritative repository or upstream. And rule 4 is regularly sync with the UFS weather. We don't want to stay as a fork without syncing with the UFS weather model, because who knows what will happen to the UFS weather model in 6 months. So the regression testing, we are talking about changing the regression testing system. We are talking about changing the infrastructure, etc. So if we keep syncing in a regular way, then we will be ready to any major change, and then it won't take too much time in our end to adapt that change. So for example, one of the examples that we face in the recent sync, the UFS weather model made some change in the Wavewash 3 and then introduced the use CMAPs flag. So that use CMAPs flag breaks our standalone Wavewash 3 configuration. It took almost 4 or 5 days for me to find out the issue, because it was giving error related with the PIO, but the real issue was something different. It takes a couple of days for us to fix that issue and then make our regression testing system working again. So we have challenges in the model level. The first one is we are not exposing anything to UFS weather model at this point. We are something like a black box to UFS weather model. That brings extra work to us, because in every PR in the UFS weather model, we need to solve those issues in the UFS coastal side. So possible solution could be, we could use automated testing capability. We are still exploring the Jenkins and CI/CD at this point. We have some solution, but it's not working perfectly, but we are trying to solve those issues. More frequent sync could solve the issue, but we don't have that bandwidth in our end. So, or pushing existing development to from UFS coastal to UFS weather model would be ideal, but that requires an additional decision in the top level, because we will bring lots of different components. Maybe, as I told you before, maybe we can do it in an incremental way. So, for example, if somebody else wants to use CISM in a global scale or something like that, maybe there's some interest in the HAF side to use another ocean model for testing or something like that. Maybe we can just push that specific component to upper level. At least we will have some kinds of a coverage in the UFS weather model in terms of UFS coastal applications. In the component level, yeah, we have lack of testing in the component side. So we have 4 or 5 different components. Those components is also evolving very fast. And sometimes they are not testing their component along with the development with the UFS coastal regression test. So they are changing too fast. And then once we update that component in our end, it's failing. We don't know why it's failing, because they are changing something in the model. They are changing something in the name list, so they are not following the best practices in terms of the developing. So those kinds of issues creates extra headache in our end, but we can able to solve them just by running the regression test and then reporting them, collaborating with the developers of the components, and then trying to solve those issues, but still taking time in our end. External users, collaborators. So it's great to have a UFS coastal. It's some level, we reach some level of, we reach some level, and then people start creating a different configuration. So that's great, but that also brings extra pressure in our end, because, for example, they want to couple with different components. They want to bring another variables to couple with another component. So we need to find a way to support them, train them, because it's too complex. UFS weather model is too complex. So you need to tackle with the mediator, you need to tackle with the CDEFs, you need to tackle with the component itself. So we have to provide some way to external users to at least some level of idea to tackle all those different pieces and then make their configuration working. So at this point, we are trying to have regular meeting with the collaborators, recording videos, training videos related with the CDEPs, related with the other components, and then trying to train them to be more independent. But again, that also is a challenge in our end. In the application level, we have a model, UFS coastal, and then we also create an initial version of application called UFS coastal application. So this basically drives the model, and we are using the UV tools to create, for example, data atmosphere system configuration using very minimal input. And that's working, but the main thing is that I think nobody is using the application at this point.
Yeah.
So that's the main problem. So we need to push the users to use the application rather than using the model. Then we can improve the application. We can bring more configurations. Yeah, we develop, we are testing it, it's working, but again, if something changes in the model level, if something changes in the component level, it will affect the application, and then application could easily break. So we have to find the right way to solve those challenges. Am I fast or no, on time?
You're great. Actually, you left 2 minutes for Q&A. So if you have like maybe 1 or 2 questions.
Yeah, I think these issues is very generic. So if it can be easily applicable to UFS weather model, I think.
Okay. Hi. Okay, that's working. Great presentation. That
Thank
was
you.
really enlightening. And we've seen this week that NOS is really like pushing the boundaries, a lot smaller, able to do things a lot faster. But as you just said, no one's using it yet. What do you think the obstacles are there, and how will we get to a place where that's like the default?
I think we are still in a process of reaching a much more mature level, because relatively the UFS coastal is relatively new. So last couple of years we are trying to develop, the application is developed maybe 6 months ago or something like that. So we need more user base, and then we need to extend the application, because at this point we are just supporting a single configuration. So we need to expand. But again, this is related with the resource. So we need more more funding maybe. For example, maybe somebody else needs to work in the application side. Maybe somebody else needs to work in the component side. So it's very complex. And UV tools is also evolving too fast.
Yeah, at this point, I think we have a team of 1 people developer. And I just want to like quickly regarding the application. I think the application repo to me is more for testing if the components are working together fine. Essentially, people are gonna fork from that, start build their own specialized application, as like CCOFs or Stuff 3D Atlantic, Stuff 3D Alaska, for instance. And I know that our colleagues from Great Lakes already start using UFS Coastal for their coupling applications. And we see a lot of more kind of user coming in, and the maturity was important, because previously we couldn't even support them to compile the application correctly. So how can we advertise it as a potential kind of code base for their base project? Because they have a deadline, they have to provide. So, but now we are at the level that we can do that. Maui, please.
So actually, Ufuk, I really appreciate your effort, because I can feel your pain by, as a single-handed person, to try to sync between UFS weather model and UFS coastal. So I think that's one of the things we need to address to Saeed's earlier points, to bring UFS coastal closer to the other side of the UFS. So my question to you would be, do you know if there is any of the coastal models that you are working with coming with a complete unit test suite? Because on the UFS weather model side, we have started a multi-year process to look into the component models to develop unit testing for them, so that we can change them into libraries rather than keep them as sub-modules. In some way, in my view, that's a way for us to merge the 2 models, because then you don't need to worry about other component models if that happens.
My personal impression is that the model developers are great, so they are supporting us in a different ways, but they are a little bit far from using the best practices in terms of the code development. So that was my concern. So for example, let's assume that we are trying to push one of the models, for example, SISM to UFS weather model. Then they need to dedicate some time. I am talking about the model component developers. They need to dedicate some time to be sync with the UFS weather model, to follow for example, even when you change the compiler version, their model can fail. And they need to solve this issue. So without giving this time to UFS weather model, I think there is no way to push those components to UFS weather model, right? So that's also my concern. So I think
I want to mention this is not only the concern on the coastal motor side. I just think the whole community needs to move in that direction. So we should have some strategic.
Yeah,
I
I agree.
First of all, I just want to just briefly mention something, and then we can let maybe Mansour talk. We have like 4 core models, and they are at different levels of regression testing and unit testing. And like I can name, like for instance, ATSIC they are doing a perfect job on having 80 like CI/CD, like Circle CI on GitHub. Basically, they at any push they will start doing all of those 80 or how many, I don't know, tests. So we are trying to get others also encouraged more on that direction, and we understand the value of that, but not all of them at the same level of like readiness. But thank you very much for the question. If that's okay, we would like to maybe have the podium to Mansour, moving from here. You can join me here. Yeah, thank you. Mansour, please take it.
Yep, let me share my screen.
Mansour, because of the conversation, you have like 10 minutes or so. I'm so sorry, but this here people are very tight in terms of timing, so please do your best. Thanks.
Sure. So let me see if you can. Can you see my full screen? Or?
It is in presentation mode. Yeah, do this. Yeah, perfect. Please take the lead.
Sorry. Yep. Hi everyone. Thank you for
there is that
joining my
height
presentation.
thing on the bottom. If you just maybe got rid of that, also that would be great. Thank you.
Yep. Okay. Yep. Thanks, Said. So, hi everyone. Thank you for joining my presentation. My name is Mansour Ali Jisan, and today I'll be presenting some of the ongoing work that we are doing on developing a containerized WCOS2 environment for collaborative ocean forecast system development. Before going into the presentation, I would like to acknowledge my collaborators and colleagues, especially Zach Kobel from the Water Institute and my colleagues from the National Ocean Service and National Center for Atmospheric Research. National Ocean Service operates several operational ocean forecast systems. One of them is the Coastal Ocean Modeling Framework-based Regional High-Resolution Ocean Forecast System. We also have the Storm Surge Tide Operational Ocean Forecast System, STOFs. All this, these are the backbone of the backbone behind the services that we provide in support of the safety navigation services, coastal resiliency, or emergency management. While these systems have evolved over time, we are also experiencing some of the challenges in maintaining this system. So as these systems has been evolved slightly independently, the workflows that they use are do not always look the same across different OFS. And this creates some issues in terms of maintaining the system as well as extending the capabilities. To address this, we initiated a workflow modernization initiative to create a standard, easily adaptable workflow framework that will support all the operational forecast system at the NOS. So we are hoping to develop something easy to maintain, extensible and scalable. Another key aspect of this work is collaboration. We work closely with our collaborators in industry and academia to develop the operational ocean forecast system. But one of the big challenge here is that all these operational ocean forecast system, they run on weather and climate operational supercomputing system, which is known as operational supercomputing system, where we run all these forecast systems. But external collaborators cannot have access.
Mansour, are you changing the slide on your side, or?
No, I'm actually still not changing it. Yep. But external collaborators actually cannot have access to the WCOS2 system, and this makes it harder for transition from research to operations efficiently. To address this, we developed this containerized WCOS2 environment, closely mimicking the production environment, along with a unified workflow framework and the CI/CD pipeline. So in this presentation, I'll be talking about some of those work that we are doing in this region and how we hope to efficiently to make the research to operation transition more efficient. So with that, I'll switch to the containerized environment architecture slide. So our initial implementation of the containerized architecture, containerized WCOS2 development was done through Docker, although we are currently switching to Singularity-based container for better compatibility with the NOAA's RDHPCS resources. This Docker container includes some of the essential services like Slurm job scheduler, ECFlow for workflow orchestration, and some necessary environmental modules that we use in the OFS, like setpdoi, those libraries. And there are some defined variables that we use in the JJob script in the operation. So those variables are loaded through the environmental modules. So during the Docker build process, we also build necessary NCEP libraries from their respective GitHub repo. So for example, libraries like bufferlib, libbashiel, wlib2, those kind of libraries are built during this container build process. One critical aspect of this container is these two hydrodynamic models, Schism and ETSERP, which are the hydrodynamic engine behind the Storm Surgeon Tide operational forecast system. So during the Docker build process, we compile these two hydrodynamic models, the same version that we use in operations from their respective GitHub repo inside the container. We also, our initial implementation of this container was done by executing the workflow of the STOF 3D Atlantic end-to-end workflow execution within the container. So the container setup actually allows us to execute the pre-processing and post-processing steps of the STOF 3D Atlantic. Because of the limitation of the compute resources in the Docker environment, it's not possible to run forecast, and we are currently working on transitioning to Singularity in order to address that. Now, you might be thinking how we manage this large input data set that we use inside that we use in the operational workflow. So, for example, in STOF 3D Atlantic, we use GFS, HRR, RTOF's dataset as an input to run the pre-processing and other steps in the workflow. So in order to address that, we developed this data management strategy. What we are doing here is we use the Docker's volume mapping to map the data from our local host into the container environment. So our initial implementation was done on NOAA's parallel work compute cluster. Our dataset is hosted on Lustre storage system. So during this Docker run process, we map the data from our container environment. So these are shown by this dashed line, where you can see we are replicating this exact same directory path structure that we have in the WCOS2 production environment, so that we can use the exact same script that we use in production without modifying anything. So when we execute the workflow, the JJob scripts are going to locate the file in that same directory that we use in production. So that makes this Docker containerization more efficient and easy, and allowed us to use the exact same production script in the container environment. Yep. So inside the container, to trigger the workflow, we developed this workflow framework that I just mentioned in the beginning. This is something we are hoping that it will unify all the workflow across all OFS. In this, this is a Python-based workflow manager where user can execute pre-processing, nowcast, forecast, post-processing through this command line interface. So this workflow package broadly has three layers. One is the configuration layer, one is the model framework layer, and the execution layer. So through those different layers, we execute the system configurations, as well as there are some levels of model-specific levels which we trigger inside through this command line interface. We are also working on developing a CI/CD pipeline to maintain to have this operational forecast system more reliable. So we are utilizing this Docker environment by combining this GitHub action workflow and parallel works execution. So with on every push and nightly build, GitHub action build a fresh container, push it on the GitHub, push it on the Docker Hub, and on the parallel works we schedule the execution of those container image by pulling it every day and run the pre-processing, nowcast, forecast, and post-processing on the Parallel Works platform. So this ensures that
1 minute sharp. Yes, thanks.
Yep. So this ensures that the system is functioning as expected with all the available libraries. So currently we are working on, as I mentioned, transitioning to the Singularity container for better adaptability with the RDHPCS resources. And we are also planning to switch to the CI/CD, our CI/CD pipeline into the Jenkins-based CI/CD for better adaptability on the NOAA's RDHPCS system. So I'll not spend much time. And so here's the summary slide, and I'm happy to take any questions. Thanks.
Thank you very much, Mansoor, for accommodating that. Thank you. Let's give a round of applause for our presenters.
Thank you to our chair, Saeed, as well. All right, so our next session is commercial weather observation. So if our two speakers, I don't know if they're virtual or here. Oh, they're both here. Hi, guys. Michael Horowitz from WeatherStream and Thomas Cavett from Tomorrow.io. And then we are going into lunch after this.
All right, good morning. My name is Thomas Cavett. I am from Tomorrow.io. It's a weather intelligence software company. I lead our federal business. My background is I was in the Army. I've done various startups and kind of consulting roles before I finally landed in space and in weather. Helped to start our space program. And as I said, now I lead our federal business. I also do some other things across sort of the ecosystem. Founded the Commercial Weather Alliance, which is a group of about 10 companies, which Michael's also a part of. We advocate for weather and space-related policy issues. And I'm also on an advisory committee within the Department of Commerce on environmental technology. So thanks again for having me today.
Appreciate the opportunity to be here. Michael Horowitz, co-founder and CEO at WeatherStream. I've been in the tech transfer world for most of my career, so my sort of core skill set is taking research from a laboratory environment and working through the commercialization issues. Undergrad in physics and public policy, been the principal investigator on projects for Department of Defense, NASA, and NOAA, including the Neon Simba mission is the most recent project we've worked on with NASA. And just recently, in the past few months, accepted a role with the WMO in the Standing Committee on Earth Observation and Monitoring Networks as the hydrometeorological environment industry representative. So my role there is basically represent 140 global companies in the weather space as their policy representative to help shape the frameworks for how commercial and government work together. So I think today we have some exciting topics to discuss together.
So just a quick kind of overview of what we're going to go over. We'll kind of give you a bit more background on the companies that we represent. We'll talk a little bit about our perspective on sort of the history of the weather ecosystem and the value chain and how it's changing from a commercial perspective. We'll talk about our own sort of observational contributions, let's say, and then our relationships with some of the other government agencies that we work with. And then lastly, a bit about our thought process around sort of the future state and where commercial is driving the industry. And then would love to open it up to discussion on some of the sort of broader policy and issues that we'd like to talk about. That's still me. So Tomorrow I.O., as I said, we are a weather intelligence software company. We started out as a software company back in 2016. We've got about 150 employees worldwide. We also have an office here in Golden, just down the road. We've raised over $300 million to date, and we serve a really diverse array of companies, which you can see just a small sample of at the bottom. But this ranges from major airlines to, we're in every Tesla vehicle, helping to calculate things like battery life. We're in the Uber algorithm. We work with shipping companies, with sports teams, you name it, anybody who's obviously impacted by weather in various ways. And then you can see sort of this band across the middle here, some of our satellite launches over the last 2 years, beginning in 2023 with our first Pathfinder radar systems, which I'll talk a little bit about. These are K-band precipitation radars, the first ever commercially built weather radars in space. And then since then, we've also deployed an additional 7 microwave sounders, and we plan to keep launching more and more of those. So sort of a fast overview of what we do as a company. And here you can see a bit more about our constellation itself. So our overall goal has really been working backwards from our user requirements, thinking about as we've developed our software platform, as we've begun to run our own weather models, how do we really improve data gaps globally? And ultimately, that's sort of what drove us to launch these satellites into space. So as I said, we've launched 7 microwave sounders. We plan to launch about 14 in total, with the goal of achieving a revisit rate that's sub-hourly globally. And then our precipitation radars, the first 2 that we launched were a sort of simple parabolic antenna system that's meant to prove out the digital backend, the software-defined radar component, and the scanning and the beamforming and some of the other aspects of the data pipeline. But then eventually we plan to migrate that into a much larger swath instrument that can provide a much better revisit rate globally, which we're still in the process of developing. Again, kind of the goal here is really that sub-hourly revisit rate, and that's where we really start to see a lot of the forecasting improvements, is when we can maintain that sub-hourly revisit rate for both instruments. We're continuing to launch those sounders over the next 6 months or 12 months. We'll launch another 8 or so, and the radars we expect to begin launching in roughly 2028. So just to give you a sense of the timeline.
And just a little bit about us. Our mission as a company is to stream real-time weather intelligence globally in a commercially sustainable way. And we have also a company science objective that we've set out for ourselves, even since before the company was formed, of achieving Nyquist spatial and temporal sampling of the environment with passive microwave sensors. I'll speak a little bit more about the spatial component of that later. A little bit about us. We're the world's first commercial microwave mission. We started out at CU Boulder, just down the road here, in 2015, based on a lot of research into miniaturized sensors and radiometers for various platforms. Today, we're about 34 employees, 13 PhDs, 18 engineers, so a very technical team. We like to say that we're civil servants trapped in a startup, and that we have this mission that we set out to achieve, and it seemed like the best way to do that was through a sort of a new entity. We're all about working with others, relationship and partnership driven. We a whole team of people that love the outdoors and go on adventures. And I guess just an open call. On October 4th, we're going to hike a V-band hyperspectral radiometer to the top of Mount Bierstadt to measure the oxygen spectrum. And that's, if anyone's interested in joining, just send me a note, and we'd love to have you come on that. We've got a backpack-mounted instrument we developed that will enable the research. And we use a mantra in the way we design instruments. We say every photon is sacred, which is just essentially we really try to design instruments in a way that really pays attention to data quality. And I guess the thing maybe we're most proud of is we're fully bootstrapped to space. With our second satellite mission is in production and ready to launch now. So we're working with the broker to get that on orbit here, hopefully by February. So I'm looking forward to that very much.
All right, so first we'll talk a little bit about kind of the background of why our companies are able to achieve what they are today. And if you think about the history of sort of our industry here, traditionally the capital intensive aspects of this were dominated by government, right? The satellite systems that have been put up over the last several decades were very expensive, billion-dollar systems that took decades to develop, decades to deploy, and they were meant to last a really long time. And the result of that was that the technology was often outdated and is often outdated by the time it's on orbit. And so the sort of hardest parts of the industry were done by government. And then the commercial industry was really just doing sort of value-added services, right? Receiving that data from the government and then maybe providing meteorologists as a service and some software on top to add to it. But that's changing pretty dramatically. Can we go to the next slide? So now commercial is really in a position to play a role across the entire value chain, right? We're really innovating across all three parts of this ecosystem here. And there's a lot of key drivers that are enabling that, things like lower cost of launch, lower cost of components to build these sensors that we're putting not just in space, but in other parts of the atmosphere. Sorry, this thing is cutting in and out. High altitude balloons, drones, et cetera, which are all contributing to sort of new novel forms of data that are impactful. But it's also things like the cloud, right? The ability to build systems that are more dynamic, easily updated, and cheaper to run. And ultimately, we see commercial evolving into a much more impactful role as a partner rather than just a sort of receiver of everything that's happening from an innovation standpoint.
So we wanted to use this opportunity to kind of highlight that we don't necessarily view the world as government versus commercial. It's really an opportunity to do more together. And I think there's a number of benefits that we see from our perspective in industry of how industry can help the overall mission of the weather community. The industry, to Thomas' point, we're not reliant as a government as the only customer, and so there's a lot of ability to share costs that comes from that. There's additional capital available from the private sector that enables the development and deployment of new technologies. Of course, comes with different motivations and opportunities and challenges, but additional capital is something that's always needed to move things forward. And then, of course, the risk versus reward incentive structure motivates rapid progress, differentiation of products and services, and ultimately optimizes the value chain for different capabilities in different parts of that value chain. And so we see sort of two main themes we think are important to discuss and collaborate around is think of industry as a partner to help augment the government systems. The more the industry can take on, the more resources that frees up to help the government fund backbone capabilities like the NEON program or GeoXO. If we all work together, we can hopefully develop better mechanisms for public-private partnerships that enable a lot of these things to happen more quickly and ultimately serve the diverse array of stakeholders that we're all working for. And just thinking, it's not just we work primarily on commercial satellites, but there's commercial companies providing sensors and data services in just about every sensing domain at this point. And there's competition in all of those sectors as well, which is driving innovation, different capabilities, different focuses. Many companies, especially like Thomas and his team are working on, are also developing modeling and data simulation. And so really there's a lot of appetite to be able to collaborate and contribute to all these complicated problems. So I think if anything, it's sort of we're at a new dawn, so to speak, of having so many different things that can be leveraged to help with these complicated problems.
Great. So just to give you a sense of the, quality is obviously a really important concern here as we're developing these systems where we're taking a lot of risk, we're pushing technologies that don't necessarily have much heritage in space. But just to highlight here that, with our precipitation radars, for example, we've done comparisons internally against things like MRMS, where we see higher correlation to MRMS than from GPM, for example, which is what sort of the core mission idea is based off of. And then also we've had analysis done by NASA's CSDA program that shows really high data quality. So we're not only internally validating and publishing our own science about this from a commercial standpoint, but then getting that validation from governments as well. Go to the next one. And then similarly with our sounders, so our sounders are actually based off of the NASA MIT Lincoln Labs Tropics mission. We took that design, we added an additional calibration target and some other sort of improvements to the design to make it more robust and easier to calibrate. And you can see, if you sort of watch the storm convection movement across the image up there, that's just current state. We're at about 6 hourly coverage with just our systems. When you add that in with kind of the currently on-orbit government assets, obviously it's even lower, and then we'll be achieving even lower revisit rate over time. So you can see we're already covering a significant amount of the atmosphere. And at any given point today, if you were to look at the atmosphere, 44% of the time, the most recent observation is coming from one of our microwave sounders in terms of microwave measurements. By the time we're at full deployment, that will be 75% of the time. So really dramatic improvement in revisit rate. From a calibration and validation standpoint, we've compared this against not only Tropics, but ATMS and other systems, and we show really high data quality from a much, much cheaper instrument that's a lot easier to deploy. So that's what really enables the scale that we're able to achieve and that improvement in revisit rate. We often have conversations with government customers where they say, oh, what about this LTAN or what about this orbit? And when you've got sub-hourly revisit rate around the globe, those paradigms become less relevant because you're able to see almost everything in near real time. So, and just lastly, I kind of already spoke to this, but luckily these images are working. I was afraid they wouldn't, but you can see sort of the current government programs of record in that top right animation, and then when you add ours on top of it, you see the additional coverage that we're achieving, and this just talks about that age of data and the ability to see that 44% improvement. Yeah.
Cool. So let's share a little bit about the GEMS mission, or our core mission. We call the Global Environmental Monitoring System. It's now on its second generation. Similar coverage in terms of frequency bands to what Thomas and his team are working on. We have designed the sensor to achieve Nyquist spatial sampling, and a little bit different architecture. We deploy and scan just the reflector, not the whole instrument, which has some opportunities and challenges. Mechanically, it's simpler because you have a lot less spun mass to compensate for and less electrical complexity, and also enables a little bit faster scan rate to achieve the Nyquist sampling. We'll have about 16-kilometer nadir resolution. This is essentially twice the resolution at ATMS for temperature sounding, and a little bit better than that on the humidity sounding channels, which will be, in both cases, the highest spatial resolution measurements of both of these bands that's ever been made on a cross-track instrument. It's a 6U CubeSat that we're flying on, about 12 kills. So we're both flying our satellites on essentially CubeSat, smaller platforms. About a 3 to 5 year mission life is what we're shooting for. This is just the payload size, weight, and power is the 2.2U. So it's about 10 by 10 by 20 centimeters. 3 kilograms total payload mass, 15 watts operational power, about 300 kilobits data rate. You can see the weighting functions for both the temperature and humidity sounding. And I guess it's important, this is technically a 4-band system. We have window channels in W and D band, so the 165 and 104 gigahertz windows, which have good sensitivity to the surface and good vertical resolution, where we'll see temperature up to nearly 50 kilometers in the total air columns or into the upper stratosphere, with the ability to measure temperature, and through basically the full troposphere for humidity sounding with the 183 gigahertz line. So 24 channel sensor, there's actually more channels on this instrument than on ATMS. The total cost per payload is around $500K to make these, so it's multiple orders of magnitude less expensive to manufacture this sensor than heritage sensors of this class. Of course, it doesn't have everything ATMS has. Some of the lower frequency channels require larger antennas, so it's not exactly apples to apples, but the goal here really is augmenting the existing systems rather than trying to replace them. And I forgot to mention, we actually will have a fully open data policy on the first mission. We've been really lucky to receive sponsorship from both the Air Force and from NOAA for that mission. So we're working to get the cloud infrastructure up and running, so anyone that wants to use the observations will be able to use them without restriction. over time, obviously, we have to charge for some of the data, but our goal is that we'll always be free and open for scientific research, for public safety, and for just international partnerships in those areas. Where we kind of draw the line is commercial use of the data for value-added services. There needs to be a subscription, but I think that's sort of obvious business ethics. A little bit of technical data on the pre-flight assessments. So the NEDT, or noise equivalent delta temperature, or essentially the sensitivity of the instrument across channels, was really quite good. You can see here in some of the notes some of the specific things we're still working to improve for future instruments around different noise mechanisms. But essentially, we've got almost the blue curve here is theoretically maximum sensitivity. So for many of the channels, we're very close to hitting that. Then there's a couple of channels where we're working on more complex noise issues for future units that will help improve that farther. But essentially, these are very competitive, very high sensitivity instruments that also have improved vertical resolution over all the other instruments of this class. So it's really going to be exciting to see what people can do with this data, and just a few months away now. I like to make the point about Nyquist spatial sampling is I can make this point in one chart. The temporal sampling is significantly more complex, requires a longer explanation, but essentially the idea of Nyquist sampling is something you learn in like basic electrical engineering and signal processing theory, is the idea that if you don't sample a signal of interest at its natural rate of change, then you're potentially aliasing information that you might otherwise want to observe. So for Nyquist spatial sampling, which has essentially not been achieved by any operational microwave sounders to date, maybe I'm wrong, I'm not sure if you guys are doing this, but essentially with the contiguous footprints, which you can see in the lower left, you actually have spatial features that the sensors are not actually observing in those gaps in between footprints. And so the result of that is potentially loss of information about the scene below. And depending how you're using the data, that may or may not have an impact. If you're doing data assimilation for global NWP, perhaps it's a non-issue because you're already thinning the data in the DA process anyways, whereas if you're trying to produce a level 2 precipitation product, it could be a big issue, or a cloud product, because you're actually missing spatial characteristics. So with the Nyquist sampling, you're essentially ensuring as you're sampling along and across track at the rate that's needed to avoid having any gaps in the footprint of the instrument. For spatial sampling, essentially an instrument-specific feature, scanning at a certain rate with a certain footprint size. For temporal sampling is really about how you can monitor the evolution of different events. And there it's about making sure that each satellite pass is overseeing a given scene within the correlation time of the features you're trying to predict. This is a much harder problem to solve, requires rapid revisits, roughly 50 satellites to achieve that globally. And each one of those also needs to implement the Nyquist spatial sampling. So it's a tough, we're on the path being able to do this by making the sensor cost so low, but there's a lot of other system complexity in achieving that. But we believe ultimately when that data is available, we'll have a massive impact, especially on short-term severe weather forecasts. And I guess just I'll go through all of this, but we're also able to make actual contributions to the JCSDA JEDI team. They have a sensor coefficient generation package, or CGP, that's needed to bring new sensors online. And we're working with Ben Johnson and his team for some time on this now, where essentially they didn't have enough engineering and scientific support to complete that and make it fully operational. So rather than just sort of sit and wait, our team actually jumped in. We have several of our science team members have been working actively on this program together with JEDI team to make it easier for people who are developing sensors to create the CRTM coefficients needed to get that data into use as soon as it's online. So we have this running in-house, so anytime we get a new sensor, we can take the sensor response functions, create our coefficients, put them in, share it back to the community. So all this contribution is, it's up to the JEDI team of when and where to release that to the community. We're just basically doing our part to help and there's been a number of things that we've worked on. I won't go into all that today, but it was really fun to work with them. Really appreciate their collaboration on this because it helped both us and hopefully will help them with what they're trying to accomplish. They've taken on a huge program of their own. And then just last thing, just because we really want to get to the discussion, just a little bit about next generation radiometer capabilities. We're kind of dual hatting as data science company as well as hardware developer. We're part of the Neon Simba. Our small company is competing against Northrop Grumman and Ball Aerospace on next gen sensor developments. Some of the really exciting new features coming with next-gen radiometers, which really are the type of things that are complex and expensive and fit better in a backbone system than a commercial system, are hyperspectral radiometry against all the observations bands. Being able to detect radio frequency interference is a super complex signal processing problem, but obviously there's a number of issues around that. Adding new observation bands, expanding bandwidths, there's just a lot of exciting things that are coming in future systems. We're also working on a radiometer design around improving cloud ice measurements for NASA, the Atmosphere Observing System mission. We're in phase A with that. These two are still in competition, so I'm just giving like a couple of high-level bullet points. Our third generation commercial sounder is covering all the ATMS bands except K and Ka band. So that's really a step forward, and that's going to fit in a much smaller satellite, not quite a CubeSat, but not into a full-size JPSS class satellite. And one of the things that we haven't really said too much about yet, but maybe people aren't aware of, but like the microwave imagers like GPM, WSFM, SIMR, TRIM, GPM have been proven to, for a microwave imager, be like the most important sensor for accurate precipitation observations. But the current cost of these systems is hundreds of millions of dollars for an individual payload. And so we've been funded from Space Development Agency, Space Systems Command, and with internal development funding, develop really low-cost microwave imaging payloads, some conical scanners, large deployable reflectors. We're developing these basically optimized around level 2 product generation, ocean surface vector winds, tropical cyclone structure, sea ice, snow depth, precipitation rate and phase assessments, and so forth and so on. So a lot of really great products that come from microwave imagers. The cost of these has been prohibitive to their mass deployment. There is no microwave imager plan to follow GPM. NASA and NOAA don't have that in their 10-year roadmap. There's no decadal survey requirement for it. So we're aiming to drop the cost of these payloads to under $10 million in this development work. That will enable yet another important data set to be done commercially.
Just similarly, so with both our Pathfinder radars and our microwave sounders, we've been working closely with the Air Force through their Air Force Lifecycle Management Center and the Air Force Weather Service, with DIU supporting that, as well as the Office of the Secretary of Defense. And then on the civil side, both with NOAA and NASA in their commercial weather data pilot, and then the commercial satellite data acquisition program. So if you're affiliated with through the ROSES program or work with NOAA, you have access to these pilot data sets. And we encourage, obviously, as much access and experimentation and working with them as possible as we continue to deploy our systems. So.
And I won't spend too much time on this. We've primarily done work with DoD. We've done a few projects now with NASA and NOAA, and just doing our first project with the NGA right now. So we're doing a lot of hardware R&D. I won't go through all of it. But we're also doing some work on data assimilation, on level 2 products, nowcasting, just starting a couple new projects up as we speak on next generation instruments. So, government R&D has become sort of our bread and butter, but we've got a lot of great customers. Very grateful for the opportunities that have come both through the SBIR program as well as full and open competition programs. And just to be able to start in a lab and be contributing on the sort of international scale has been a really fun adventure, to say the least.
We've mostly been focused on the observing systems, obviously, today, but one of the biggest trends, obviously, that everyone, is well aware of is just how AI is disrupting really every piece in this value chain that we're talking about today. And I think one of the biggest changes is just the ability to ingest more observations. And we've, from a Tomorrow I/O perspective, realized that as these models become more and more commoditized, one of the biggest differentiators is going to be the data sets themselves. And so just being able to develop bigger, more comprehensive observing systems is really going to be what makes the biggest change here. So we're excited about this trend. We use AI throughout our entire stack, from how we're tasking our satellites to our ability to run the models, and then from a sort of agentic way in our software platform and how users interface with the data. So it's really making significant changes that we're excited about.
And with that, we had prepared a handful, I think 2 more charts, which are really intended to facilitate a discussion with everyone here. So we have policy, market, technology, and opportunities and challenges as the themes. So we'll address policy and market conditions first. we didn't necessarily want to just read these. We really wanted to throw these out there as topics of interest and kind of invite the group to jump in if anything is top of mind or anything you want to ask. Starting with sort of the data policies themselves, the history of that and where they go and how it all works. But yeah, we'll pause there and see if there's any burning questions or discussion.
Coming in from online. This one says, to Thomas and Michael, you discussed private sector and government partnership. What is your vision for private sector and academia partnership using data assimilation as an example?
Yeah, I'll give a few thoughts. I mean, we work with research institutions all over the world on a wide range of programs. That's always been, I mean, that's where we started. It's core to our DNA. We do internal and external R&D. One specific example, working with the University of Wisconsin in Madison on data assimilation for future hyperspectral radiometers. When you have thousands of channels instead of 20 or 30 channels on instrument, how do you make use of that data? It creates a number of new opportunities, but also challenges. A lot more data to maintain, has a massive impact on cost of processing, storage, transmission, distribution, quality control, et cetera. And so we believe that partnerships with academia are really important to us and something we're always interested in doing more of. We're a small team. Sometimes we don't know all the great work that's going on out there. It's hard to keep an eye on everything. So, we're very approachable. Always happy to discuss ideas. If there's research programs that can benefit from our data, we'd love to hear about that. We'd love to work with you and make that available for your research.
Yeah, I mean, we approach it in really the same way. We work with multiple academic institutions across that entire spectrum, from building DA tools for our radar systems to running OSSIs to validation and calibration campaigns that we're running. So we see ourselves as a kind of integral part in the whole sort of R2O, O2R ecosystem and life cycle. We also, and this is touching a little bit on the policy aspect of this, but from a data policy standpoint, we make a really clear distinction between operational forecast data and data used for science. We very much want to continue to support the science. It benefits us just as much as we benefit it. And, where we make our money is more on the operational data side. And that's where, to survive as a business, as Michael kind of alluded to, we have to, think about things a little bit differently than the way it's been done in the past. But yeah, it's super important.
Are you still having a slide that you haven't shown yet because you had 4 instead of 2?
We do, yes.
I'll take a look at that later. But on the first slide, I'm very appreciative of the fact that you want to change the open data policy. There is just one problem with that. It's not that the government doesn't want to do that, but through WMO, we have international agreements that the data needs to be open. And the reality is that we can label data as not being that. For instance, some of the marine data from the Navy is classified. So there are ways of doing that. And then secondly, so that's an international treaty. Secondly, there is this law that if the government pays for your products with tax dollars, there are some laws in place that don't allow us to double charge the taxpayer, and so that also means that they need to be open. So I'm be very interested in seeing how we can get around these things, but if you feel that the government is not responsive, that is because of, or is just playing difficult. We are in the harness here of international treaties and of law.
Yeah, totally agree. As I think you're alluding to, there was WMO Resolution 40, which was then replaced in 2021 by what's now called the Unified Data Policy, or Resolution 1. There are different classifications of data, and how they determine which data has to be shared is more at the technical level, not at the policy level. But there are really important caveats in the new data policy, and if you read through some of the appendices that allow for negotiation and sort of taking into account these commercial business models and the ability to negotiate licenses. And even if you look at NOAA specifically, some of the recent RFIs and RFPs over the last 2 years or so have a menu of licensing options. The new Weather Act reauthorization that was just passed in the House committee just this past week or last week also talks about the ability to compensate for sharing amongst multiple parts of the U.S. government. So I think there is a policy change that's happening, right? And I think one of the key aspects of this conversation is, we sort of gloss over it and just talk about data, but there are many subsets of data, right? There are time embargoes, there's latency issues, and all of those can impact, what we can or can't sell, and also its utility to a government user. So there are a lot of ways to sort of cut this up and make it work for everyone. But yeah, appreciate your question.
Yeah, I'll just add a few points if I can. I think we're not necessarily arguing against the policies as they stand. We're just trying to see how can they evolve to allow that commercial coexistence. I think that there's enormous benefit both from a public safety, but as well as international diplomacy, public relations, being able to share, and also just the sheer complexity of collecting global data. There's just so many values to society. So I think that we're generally supportive of that. It's just making sure that we stay in business to be able to support those missions as well is kind of the problem to solve. And part of our approach is I'm volunteering my time with the WMO directly to go support the policy discussions and make sure commercial industry is represented. And so I'm trying to do two roles. One, make sure I understand the needs of industry, and that includes companies that build sensors in all domains, companies that do forecasting services, et cetera, and understand because they all have different needs, and some of them are maybe less worried about observation sharing and more worried about model code or what have you. So trying to both understand the policy landscape and seeing the sheer amount of work going on at the WMO is pretty eye-opening. They got a really thankless job of what they're trying to do and manage all this. And then on the other side, onto your point about sort of double charging, I guess I'm trying to think of whether, or we as just like any other industry, right? Like if I'm a mining company and I produce a mineral product, it's a commodity product, right? If I produce a data product as my output of my business, it's why wouldn't everyone that drives value from that be willing to pay for it as if it was any other product or service, right? Like a water bottle, you pay for all the inputs if you're a water bottle manufacturer. And so it's sort of what's the spectrum look like? We could have a less interesting business model where we sell to one customer, NOAA, and they buy and redistribute all our data how they see fit. And then are we really any different than just mission as a service versus spreading the costs out? Because one of our goals is to help keep costs down for the government. But in order to do that, we need the policy environment to enable a commercial industry to want to buy from us. So if they can get everything free by going around us to get it from NOAA, which is something we run into all the time, then getting the industry, who are obviously deriving, their insurance companies underwriting hundreds of billions of dollars a year of exposure based on free public data, but they're deriving billions of dollars a year in profit from that data. And so if we can offer them a service that would augment their business, it seems like why wouldn't they pay for it? So it's just finding that balance. It's not easy, but we're going to keep working on it.
No matter how much sense you make, unfortunately, the law doesn't always do that. And this is really a very specific part of this problem as a whole. The fact that if the government buys something with public money, we cannot be put in. We are not allowed to create a situation that the public has to buy it again. That's a very simple part of it. And so it's a really special. But because it's so specialized, there are probably ways around it.
But I mean, I'll just pick Microsoft Office software, right? Like the government pays for thousands or millions of seats of Microsoft Office, but so do I.
I'm just taking this off. So I kind of have two questions, sort of. I don't know. I'm just thinking out loud. When we think about industry and commercial sector specifically, we think of it from like a monetary interest and a competitive interest. So I'm wondering how you guys are navigating kind of competition with one another, and then the interests of the government that are, save lives and protect property, but you guys also want to make money as well, and kind of can you speak on how you're balancing that and how that looks in these complicated times?
Yeah, well, I will say one issue I often hear raised, and maybe this is partly what I'm hearing you're getting at, is kind of the social justice aspect of this, which is, commercial companies are not always incentivized to go after markets that they won't make money in, right? If you think about a more rural area where there's less people, you're not going to sell as much in theory. It doesn't really apply when you think about assets from space. We're not a telecommunications company putting fiber into rural communities where we're just filling gaps from space. And so in some ways, we're actually approaching it, I think, in a better, more sustainable way, even than the government does, where there are rural gaps in NextRad, for example, that the government also hasn't been incentivized to fill, right? So I think the competition that's driven us to lower the cost of building these, high quality assets in space is actually improving the overall system and doing it in a way that's better than the government has in the past. Hopefully that addresses what you were saying. Yeah.
Well, I guess from a commercial perspective, competition is the force that optimizes the value chain, right? So you want multiple competitors in each link of that value chain. And I think if you look, I'm just looking at the commercial satellite industry as a whole, like commercial Earth observation satellites pretty mature, commercial communication satellites pretty mature, commercial broadcast service satellites pretty mature industries. So maybe have a bit of a head start, but we kind of see that going in the same direction. You can still get the free public safety broadcast off XM satellites for weather alerts, what have you, but most of the other premium content is paid for. So I think then in terms of how we approach the market, a lot of the other companies are more vertically integrated, we think more horizontal. We don't think that it makes sense for us to try to do everything. So where we sort of stop as a company is providing quality observations and in some cases providing hardware itself, but we're not necessarily trying to also be in the forecasting business or in the early warning business. We want to develop the technologies that can help people leverage our data, but how that gets packaged and delivered to end customers. So we're more of channel partnership strategy focus, working with energy and insurance and companies in aviation, et cetera, who can serve a wide range of airlines or what have you, but not necessarily trying to build a product for an airline operator. And others, and Thomas and his team have done a great job of building a nice platform to help manage day-to-day operations. And that's not something we're looking at. So there's sort of different strategies, and I think they all have their own strengths and weaknesses. I don't know if that fully answered your question, but.
I'll just add that I think another important piece here is there are parts of this that commercial will never do, most likely, right? The core thesis for us is dual use. The ability to sell to the government, but also to create commercial value. We'll probably never do geosynchronous IR instruments because it's really expensive and the government does that really well, and there's just no commercial market for that beyond what already exists from the government. So there are pieces of this that we won't do, and that dual use is what allows us to improve that ROI to the taxpayer and get them something better for less.
Hi, I have a question to the CEO of Weather Streams. So I came from Bangladesh, one of the least developed countries in the world. So my question is to that as your company are operating some commercial satellite, and specifically like global south countries have very scarce observation. Now my question is that does your company provide special discount or any incentives or any discounted rate to the subscription of the product your company sells?
Well, with our first satellite, everything will be fully open, free, and shared with no restrictions. So that's a chance to at least get to work with the system. And our hope is that as people get to work with the data and see different ways they can use it, that they may approach us to negotiate but our general approach with other countries would be to try to negotiate, a data buy license with the Met agency or the, a different government purchasing authority, and then they can work with So we wouldn't otherwise go and work directly with industry. We'd work through the med agencies who already are sort of the authority in country for distribution and quality control of data and understand the terrain and the nuances and the culture and all the things to get the forecasts. So we don't necessarily see ourselves, I mean, we certainly have the technical skills to build something bespoke, but I think we always kind of prefer to partner first. So it'd be very easy to get access to the data and work with the data, and then we presume that for many countries it would be as simple as just negotiating sort of a government level data license for unlimited use.
Thank you. I have another question, which is related to like the finance. So you're mentioning that launching a CubeSat cost approximately 500K. So the cost differ if it is hyperspectral satellite compared to what you are mentioning.
It's about 2.5 million total cost to launch. So the 500K is the sensor cost. Hyperspectral is maybe not such a difference on hardware costs, but a big difference on operating costs because of the amount of data you have to put through. So that more affects your ground system and your link budget and what antennas and all that type of stuff.
Okay, thank you very much.
Great presentations. Really like seeing all the new architectures with passive microwave observations, especially. A couple of questions, I think. One is, toward, how is the data quality and the consistency across the different flight units? And then wondering about sort of procedures and how long it takes to do kind of checkout, CalVal, error characterization, and then getting those into your downstream applications and how, if you have those. I think, some challenges on the NOAA side previously is even for mature flight units and instruments and observations that we're used to working with, it still takes a number of months to get those into operations just for maybe one new flight unit. So if we're talking about 7 or 14 new spacecraft and data sets to work with, that's going to exponentially increase the resources to go through that error characterization, do an impact studies, and then eventually get an operation. So just wondering how you deal with those challenges.
Well, I'm not a scientist, so I can only speak to it at a high level. I will say that we've been able to achieve a pretty dramatic reduction in those timelines down into weeks and days to commission and start getting science data down from those systems, and also achieving kind of cross calibration across the constellation and continuously looking at sort of the data quality, comparing both internally and externally to other like ATMS and other systems. So we've, through our work, especially with the NOAA Commercial Weather Data Pilot, kind of opened their eyes, I think, to a newer way of doing things in a much faster way that still produces high quality science data. So it is very achievable. I don't have the slide with me, but we have this plot that shows sort of month-long commissioning schedules for most government assets, and ours is like 45 days, all in. So pretty huge reduction, and we plan to kind of keep reducing that as we get better at it and launch more satellites.
And we're getting the time cut off, but I'm happy to keep going a little bit longer. I think we're having a good discussion, so can
Yeah, I was going to say we're at lunch time, so if you want to stay and finish your thoughts, you may.
Cool, I'll at least answer. Of course, you asked the most loaded question possible, so I will try not to go into a total rabbit hole. But there's a number of things. There's the pre-flight intercalibration, unit to unit. There's one of the nice benefits of moving to hyperspectral radiometers is they will really reduce the amount of inter-instrument variance by using digital spectrometers and maintain consistent spectral response from instrument to instrument. So that moving from analog to digital radiometers will have a big impact on the variance from one unit to the next. But then no matter what you do, there's going to still be instrument to instrument bias and CalVal work that needs to be done. We view that as a great opportunity for a public-private partnership. We're doing what we can internally. We were just over at NIST Boulder just a couple days ago talking about the antenna metrology and how can we really come up with traceable standards for pre-flight calibration and also the intercalibration once on orbit. There's really a number of techniques you could use, some of which are being done, others that maybe aren't being, like putting beacons at the top of mountains to transmit specific pulses, specific times to help calibrate, et cetera. There's a lot of work that can be done there to help with that overall latency, but we totally understand it's one of the grand challenges of going from one launch every 5 years to 10 or 20 a year.
Hendrik, you're keeping everyone from lunch.
Yeah, I am, but I have a very, very fun far left field question that is completely out of here. So with the commercialization of space, and you were just talking about not 1 but 20 launches a year. Do you guys think that the Kessler effect of having problems with low orbit space junk is going to be a problem with your business, or do you think that that's a complete red herring?
Yeah, absolutely. I think it'll be a problem. I mean, that's other companies.
Before or after your retirement?
Hopefully after, but hopefully we're able to build a solution that, makes a legacy that lasts longer than that. I think there are other companies trying to solve that problem that we're just going to, sort of take benefit from whatever solutions they come up with, right? I mean, even all the space traffic management efforts are being commercialized now, as I'm sure you've seen. So hopefully there will be solutions. But we do all of the sort of debris mitigation, rules. We follow all of that and do our best. Yeah.
Yeah, exactly. It's something that really requires a whole of community effort for anyone using the space resource, which includes governments, international collaboration, industry participation, and technology development, right? We also have the technologies for monitoring the debris, and especially as there's more and more. I mean, I think we're going to see driving as the LEO communication constellations, which for us are already starting to pose a threat to the passive spectrum. So there's the other issue. What we worry more about in our day-to-day is interference issues from these massive communication networks. To get to the Nyquist spatial sampling and temporal sampling, we only need 50 to 100 instruments on orbit from the global family of systems, not us, but like the whole family of systems to achieve that, which is orders of magnitude less than are being talked about for some of these communication constellations. But at the same time, you can SpaceX leading by example with having a really robust deorbiting plan and making sure their satellites are coming down on time. So there's still the like older dead space, the on-orbit stuff that's out of fuel, out of communications, and just drifting is going to always be a threat. Some of those orbits are going to go on for hundreds or thousands of years. So, I mean, there's also tech development on how to remove it, et cetera. This is a complicated question. It's something that we'll do what we can to contribute to, but obviously won't solve it ourselves. Yeah.
Thank you. Let's do a round of applause for our speakers. Thank you guys for coming. And you guys will be around for lunch. If anyone has any questions, maybe they can come find you.
Yeah, sounds good.
Okay, great. Everybody have a great lunch. Be sure to come back. We are doing citizen science and another, the Wings Fellowship, and also some interactive stuff. So Hello. We are going to start our next session. I'm really excited about this session on citizen science. I think something we could all, as activists in this area, be more involved in. Our speaker today is Noah Newman, and he is coming from CocoRa's headquarters, which is Community Collaborative Rain, Hail, and Snow Network. I like CocoRa's more, so come on up, Noah.
Hi, everyone. Thank you so much for having me today. I'm really excited to present to you guys. My name is Noah Newman, and I'm with Colorado State University, just up the street from here, about an hour north. Yes, Noah has proven to be somewhat of a confusing name in our line of work. So, let's see here. Oh, there we go. I first want to thank NOAA's Office of Education, who has been a primary funder of ours for many, many years, and we couldn't have done the work that we have done or gotten to where we are without them, as well as Colorado State University and our partner team, CIRA. So, CocoRa's, standing for the Community Collaborative Rain, Hail, and Snow Network, started out of an event that occurred in 1997. There was what was called the Spring Creek Flood, and it caused $200 million in damages to the university, as well as 5 lives were lost. But what came out of it was, at the time, the challenge of figuring out where it rained and how much was actually a much longer process than what we have today. This map you see is not a topographic map. These are inches of precipitation, of rainfall over this storm period here. Back then, what it was called was a bucket survey, where you'd put ads in newspapers, literally knocking on people's doors, asking if they had a bucket in their backyard. Can we stick a ruler in your bucket? And after about a 3-month period, we were finally able to put together a map that looks like this, where we could see on the west side of town, we received nearly a whole year's worth of precipitation, whereas on the east side of town, where the only automated rain gauge at the time was situated, only measured 2 inches of rain. And so it was really an eye-opening event where those people who had the buckets in their backyard said, you know, we've got this new internet thing going on, and I could put out a rain gauge if you wanted to. And so it was kind of a bit of a top-down, but also a bottom-up community approach to figure out how we can figure out where it rained and how much. So again, the problem that we're solving, of course, is that variability of precipitation. This is something we've all seen. You look out the window, you can see it raining across the way, and oftentimes not on you. And that variability is just something that, again, we all see, but it's amazing to see when you actually look at our maps on a daily basis. You know, oftentimes we've got lots of radar and satellite data that are estimating the amount of precipitation that's falling, but it's the people on the ground who are measuring it who can confirm and validate those radar and satellite estimates. So it's in our name, it's in our acronym. What do we measure? It's rain, hail, and snow. We do not do temperature, but we do have a few other types of observations. Our main philosophy, though, is that we're sticking to the water cycle, and it has to be a manual measurement. And so you can see here, the only requirement that we have is the use of this manual rain gauge. We don't allow automated gauges for a number of reasons, but primarily we just want to be able to compare apples to apples. Everyone in the network has to use the same type of rain gauge, and it's got precision and accuracy to the nearest hundredth of an inch. Now, we also are involved in Canada, and so there are options for having the exact same rain gauge but using a metric inner tube. I brought a prop. I got the rain gauge with me here, and I'd actually like to demonstrate how this thing works. So I'll speak up while I step away from the microphone, but it pretty much has a funnel. You've got this inner tube, and you've got your outer cylinder. This, in theory, is all you need to measure rain. You could stick this outside, wait for it to rain. In Colorado especially, that's not going to happen too often, so I did bring myself some precipitation. Get your umbrellas out here. Ooh, that's a pretty good rainstorm right there. Now again, in theory, I could take a ruler and just dunk this in here and measure to the nearest, however good my ruler is, maybe to the nearest 1/10 of an inch if I've got little markings in there. And I can, just even estimating here, I can say, well, I don't quite have a full inch, but I've got probably more than 1/2 of an inch. And that's where this inner tube comes in. This inner tube is calibrated to hold exactly 1 inch from this cylinder here. So it's got 100 little tick marks up and down this whole thing, measuring all the way to the top where it says 1.00. So I'll put the funnel over my inner tube, pour it in. Now with precision, I can see that I have 84 hundredths of an inch, 0.84. Really easy to do. In fact, this is something that we've got 3rd graders that can do it, all the way up to volunteers that are past their 90s or even 100 years old or more. Now, of course, the follow-up question, what happens when it rains more than 1 inch? Starts to overflow. So, quite easy. You take your 1st inch out, it's got a little notch, so it starts overflowing at exactly 1 inch. You pour that 1st inch out, write it down, especially those volunteers who live in Florida who get 6, 7 inches on a random Wednesday like it's nothing. You start to forget how many times you've maybe filled this thing up. You've got your 1st inch, you pour the rest of it in. .39. So what's the total for our big giant rainstorm? 1.39. You are now trained and certified to register and submit data to COCORAS. Now I also talked about snow. When it comes to snow, you take your funnel and inner tube out and you let your outer cylinder collect the snowfall. Whatever falls in, you can now take inside, you melt the snow, you pour it into your inner tube, and now you can figure out how much water was in your snow water equivalent. You can do the same thing with the total amount of snow that's been accumulating all winter long. You take your rain gauge, you stick it upside down, and you cut a biscuit. And you take a fly swatter or a spatula, slide it underneath, flip it around, now you got a core sample. Again, take it inside, you melt it, you measure it, and now you've got your snow water equivalent for your total amount of snow on the ground. Easy to do. Who uses the data? Gosh, it's almost sometimes who doesn't use the data. Precipitation data is so important for so many reasons. COCORAS, I'll step back to the microphone now. COCORAS is the single largest source of daily precipitation data that the National Weather Service uses. I'll say it one more time. The single largest source of daily precipitation data used by the National Weather Service. And the snow data that I just showed you, that snow water equivalent, is used by NOAA's SNODAS, or their full acronym, the NOHRSC, the No-Risk Group. We're a full 3/4 of the snow water equivalent data that are used by them come from CocoRa's. But of course, it can be used locally by yourself. You might be a farmer or a rancher. Really important data to know how much you got, or maybe how much it rained on your neighbor's farmers as well. Here we are, our map showing that we're in all of the United States, also Canada, Puerto Rico, the Bahamas, even Guam now. And we have, actually this number, I just looked it up this morning, we're actually over 28,000 active volunteers. And every single day we get about 16,000 reports. And since 1997, we've been sitting on now 81, almost 82 million records to this day. Here's a chart of our growth. These are daily reports coming in. It starts in 2010. Even though CocoRa's began in 1998, we just started in Colorado, and we had more states kind of knocking on our doors, asking if they could join. And so by 2010 is when we were really in all 50 states. And so you can see our growth throughout the years, and it continues to this day. We keep on growing. One neat aspect of our data are now that several thousand of our volunteers have been doing this for long enough, not quite 30 years, to become a true climate normal. But when you've got 10 or 15 years of data, NOAA has what's called pseudo-normals, where they can use station data and do some extra work and extrapolation and create normals at points where our volunteers have been reporting. So we've really been a supplement to the co-op network for our time, where the co-op program has been around since 1890, but as you zoom in on that co-op map, there are huge gaps. And so the CocoRa's network was really designed to be able to fill in those gaps for the co-op program. And now we've got over 5,000 stations that are providing pseudo-normals for NOAA. How to access our data. It was talked about a little bit in the previous session about an open access policy, and that has been our philosophy from the very beginning. We have always offered our data totally free, totally open to anyone that wants to use it. Then, of course, we turn around kind of like NPR and we give it away for free, but then we beg for donations. We do have I've put in quotations, an API. It's more like a URL generator where you can access the data through the parameters that you want, and then it gives you a URL where you can download it in various formats. For those of you who are climatologists, the platform called SC ACES is a fantastic tool where our data are available, as well as the PRISM Climate Group out of Oregon State, and the regional climate centers that NOAA supports, and the now private organization that works with NOAA, the Synoptic Data. They also house our data. And so we also have built our own data access platform, thanks again to NOAA's Office of Education, and it's called our CocoRa's Data Explorer, where you can look at your own station, or you can find any station in our network and pull up a brief, the landing page of a station will show the number of observations and a little calendar where you can see if you've got missing data. But there's also, along the top there, you can see a line of tabs, station overview, climatology, precip summary, etc. And here, just for instance, on our climatology tab, you can not only access the monthly climatology of your station from either NOAA or PRISM, but now you can also compare your own measurements for your month to date, your year to date, or even your water year to date. And you can immediately see, based on the little speedometers, if you're below average, within average, or above average for that month, year, or water year. And so the landing page for this Data Explorer tool, oh, no, I got to show you this one first, actually. This is one of my favorite graphs. Precipitation data is just so variable, even for one station. Here's over 100 years of data from Grand Junction, Colorado, and you can really see no month is ever the same. So precipitation data, unlike temperature data where we're seeing clear trends, upward trends, oftentimes at one specific location, it's hard to necessarily tease out a trend. But that's where it's really neat to use our Data Explorer, where you can view any given month, year, or water year and see how that stacked up to normal. But back to that Data Explorer tool, the landing page, dex.kokoraz.org, has the ability to either find a station on the map, or you can use the filters in the left-hand column to find a station in your location of interest, or one that is still submitting data. You can sort these metadata on the right-hand side in all these columns. So you can, for instance, find out the station in your city that has been submitting 100% of the time, or 90% of the time or more. So you can find a station with complete data and then dig into that Data Explorer for that particular station and see all sorts of fun stuff. So I know I did have a half an hour of time here, but I did want to leave it open to some questions, comments, concerns, criticisms, complaints. Complaint, yes.
Hello? Oh, yeah, nice talk. So in the beginning you said that you want everyone using the same gauge. So I have a Davis Vantage Pro 2, and I use that rain gauge. I'm just curious, I would assume that some studies might have been done comparing those two different rain gauges, and do you have any information on that? And like especially just for liquid, right? For winter, that's going to be more problematic. I can understand that because with the Davis Vantage Pro 2, some people will have that heater, others won't. I don't, and so the snow won't melt properly. But yeah, I'm just curious if you know of any studies.
Yeah, no, you hit on the exact talking point. When it comes to snow, automated gauges really fail, whether it's because they don't have a heater involved, or sometimes those heaters can cause sublimation itself. When you've got snow that's packed in there and a little heater that's trying to melt that snow, you end up losing some to sublimation as well. But just rainfall itself, there's actually been a number of studies that have proven a number of things when it comes to the differences of these automated gauges. If we were to allow automated gauges such as Davis, which is a very fine instrument, no doubt, but it's sometimes a matter of that people like to put them up on their rooftops where wind is going to be more of a problem. So having the manual gauge helps us control the fact that someone's not going to be putting it up on their roof. It's going to be somewhat at an eye level or lower if you're out in the true open area. But what they've actually found are the main problem with these automated gauges are a couple actually. But one is if you've got a Davis, and sometimes it's a tipping spoon or a tipping bucket, even the wind can shake that instrument and cause false tips. And so we don't want someone to just not quite pay attention to what's going on outside. They're looking just at their readout and they trust what it says, and it could be way off based on a windy event where it shook the rain gauge. And then there's also minor issues where rain will fall into the tipping spoon, but not quite enough to make it tip. And then a few hours later, the sun comes out, and that evaporates, and so you end up with an under-report instead. So it's those reasons, and also just the fact that we are trying to compare apples to apples and have everyone using the exact same rain gauge makes the data trustworthy. Great question, thank you.
Yeah, so you actually kind of touched on the question I'm about to ask, so thanks for the segue. But being a manual process, you know, there's still a lot of room for human error. What kind of measures do you put in place to kind of, you know, keep the results as close to the what actually happened as possible?
Sure, excellent question. The most common error that occurs is a person that will report 7 inches when they meant 7 o'clock. So that happens, by all means. The answer is that we've got a number of layers of quality control, quality assurance that's helping us here. We do have some built-in data entry pre-errors that will say, did you really mean 7 inches? When you land on a round number, for instance, you report 6.00, we'll have a are you sure type of pop-up that will have them agree or make that change at that point. Other than that, though, we have one full-time member of our team, and really more like 1.5 of people that are every single day looking at the maps and comparing it to radar and satellite, and even some automated systems that we use that will detect if a specific report is 3 standard deviations outside of its next nearest neighbor. So we've got that. And then finally, as our data leaves our system and goes to NOAA, to NCEI, in fact to the GHCN, the Global Historical Climatology Network, they themselves have their own set of QC that will automatically throw something out that might not be correct, whether it's a false 0 or something that is outside of a number of standard deviations.
All right, thank you.
Yeah, thank you.
For those of us who live in regions where we may get more than 12.5 inches of snow in one observation cycle, how is that typically handled?
Yeah, so there is actually a different company that has manufactured the exact same style rain gauge, but a few inches taller that can hold even more. But when it comes to heavy events, we will sometimes ask volunteers, we'll send out an email blast ahead of time, for instance, ahead of a hurricane, and say, if it's safe in the middle of the storm, go out and take a supplemental measurement, and then the next morning at your normal time of observation, you can take the rest and add it all up and submit that data as well.
All right, yeah, thank you.
Yeah, thanks.
My question has to do with you being NPR-esque. What are kind of the capacities you guys have, and kind of like the goals or future-looking things that you guys wish you could look at? Because obviously you're compiling all this data. That's one of the main things you do. But are there other things that you guys wish you had more resources or capacity to work on or look at?
Funding. Funding is really the thing that all of us, I'm sure, are always wishing we had more of. With the loss of federal funding at this stage of the game, we do have some data users, like I mentioned, the PRISM Climate Group out of Oregon State, who supplement our budget, as well as we actually turn around and ask our volunteers for donations. So once a year, we hold a campaign to raise money to keep us going. That didn't quite answer what you were talking about.
I more mean, like, what would you do if you had more money, I guess?
Yes.
More data crunching or other expanded projects?
I think that where we would put, we only have, there's a staff of 5.5 of us, and so we're a lean, mean machine for sure, but we only have one person that is running our entire web infrastructure. So whether it would be to hire an extra person to help that, but really, I think if we did have more funding, we would put it towards our quality control, because there would be some more, especially ML, AI tools out there that could do a better and more efficient job at quality control of our data. So that would be where we would head, where we would spend some more money if we had it. Thank you.
Yeah, I have a. In your demonstration of data collection, you did not mention the measures for controlling debris or animal interference. If there is a certain provision for data quality assurance, please clarify. If not, can you explain how you ensure data quality, and how sparse is the allocation of the measurement gauzes, and how does that affect the quality assurance and data transferability? And also, how do you ensure that the measurement device is evapotranspiration resistant?
Yes, good questions there. We really try to have a philosophy of do your best when it comes to where you put your rain gauge. That is a big issue when it comes to the quality of our data, is where you're putting your rain gauge. You obviously don't want to put it against a tree or against your house, but many people don't have the most perfect place to put their gauge. So all we can ask is that they just try their best and put it in the best spot possible. There are times when, after several months, someone's data is just not quite looking right based on nearby observations, and we can reach out to them, and whether email or phone call, and have them maybe send us a picture of their gauge, or work with them on finding a better place to put their gauge. When it comes to maybe entering bad data, it happens to the best of us. I have made mistakes myself, but when we find an error, we will reach out to that volunteer and let them know or ask them what happened. And many, many times they say, wow, someone was looking at my data. Oh my gosh. And oh, I did make a mistake. Thank you very much. And that person will never make a mistake ever again. So it's sometimes learning as you go. Practice makes perfect. And we have to understand that human beings are behind these rain gauges. And so mistakes will happen. And all we can do is do our best to intervene and make sure that they are entering data properly to begin with. You asked about problems with evaporation.
Yes.
So when the rain gauge is put together, this funnel will prevent a lot of evaporation from occurring. And the fact that the measurement is typically once per day, just every 24 hours, there's not a lot of time for evaporation to happen. Now, we do have options for people to submit what's called multi-day accumulation. So if you leave for the weekend, you're gone for a week, maybe a school, they take the time off. So you can submit multi-day accumulation observations, and their evaporation can sometimes become a problem, especially in the winter when you don't have the funnel on and you're just collecting snow. So we are somewhat sometimes skeptical of observations that are lasting more than 1 week or 2 weeks. They're not in the same database as the daily observations that are used by the data users.
And the criteria for transferring the data, what's that? Like you said that the nearby measurements are used to check the quality, so what is the basis for that? What's the threshold?
The threshold is actually difficult sometimes to determine because of the extreme variability from one place to the next. The best thing that a volunteer can do is add extra comments in their report. We have a box to add notes and comments. And so sometimes someone will write, this was the heaviest rain that I've ever experienced in my life, and my neighbor 2 miles away didn't get any of it. So adding a comment is really what we encourage people to do to make their data more valuable and valid.
So it's not a sub-basin scale or basin scale or like that? Okay.
It is not, no.
Thank you very much.
Oh, thank you. Great questions.
I was wondering if there is any kind of flagging for maybe nearby extreme winds. I know that like our hurricane model takes data from rain gauges to try to help estimate TC precipitation, but like high winds associated with tropical cyclones definitely has us underestimating rainfall.
Absolutely. Again, those comments really help. We ourselves will sometimes flag a report. We'll set it to NA for the time being until we can talk to that volunteer. Or again, downstream, the National Hurricane Center uses our data, and if something doesn't look right, they will flag it themselves on their end. So that does happen. But for the most part, our data set is quite trusted among many of the entities in NOAA. So yeah, I hope that helped.
Thank you for the talk and the demonstration.
Thank you. I encourage you to join.
He didn't say, but I'm joining as soon as I get home. But yes, everyone, round of applause for Noah. That was very exciting. And I'm sure if you have more questions for him, you can maybe write them online and we'll get them to him, or I'm sure he'll be lurking around. You can talk to him later. Okay, next we have the Wings Fellowship transition. So if Cindy Breer will come up and tell us about our great Wings students.
Thanks, Allison. And as I bring this up, I actually would like our Wings Fellows to join me on the stage. And then we have a lightning session coming up, so it's going to be super quick. We're probably not going to have a lot of time for questions, but I really, really want to encourage you to talk to our Wings Fellows afterwards or send them an email. And we have 4 here and we have 2 online. So I'm Cindy Breer here. I'm the Deputy Director for SBS CPAS, and I have the absolute privilege of managing this program. And I just want to give you, for those of you that don't know about the program, I wanted to bring up this one slide. This is a program that we started in 2023 with NOAA WPO. We're very, very proud of this program. I'm not going to read all of that. Really, we are looking for fellows or PhD candidates. So in those last 2 years when they're writing their thesis, we are looking for them to come and join us as fellows to write their thesis. And the plan here really is that our Wings Fellows will accelerate the improvement of the unified forecasting system. And we have built a unique network around our fellows. UCAR and NOAA are partners in this fellowship. Obviously, since they are PhD candidates, they have a PhD advisor, which we very much appreciate, and we provide them with a NOAA mentor to round out the network and also bring them to events like this so that you can interact with them. So as I said, we have a lightning round, 3-4 minutes for each candidate. 3 of our candidates, and it's sitting in the right order, Emily, Joey, and Trias, which is our cohort 1 that started with us in 2023 and which is close to completing their PhDs and looking for postdocs. Emily was working on dust, Joey on satellite biases, and Trias on monsoon, and they'll tell you more of what they've done over the last 2 years. And our new fellows that is just started with us, Elena, which is here, Luke is online, and Caitlin is online as well. Elena and Luke are both working more on machine learning components, Elena with S2S, and Luke more with data assimilation, and Caitlin is working in operational weather forecasting. So with that, I have a timer, and I'm going to ask Emily to come up first.
All right, let's make sure I can actually click these buttons correctly today. All right, so my name is Emily Faber. I, like Cindy said, am a PhD candidate. I am finishing my PhD shortly. I actually submitted the last bit of my dissertation to my advisor yesterday. So we're coming up. And like she said, I've been working on dust emission schemes for the past couple years, and I have been able to attend and present research at various conferences kind of around the world, actually, including AGU, AMS, of course, UIFCW. I've done some webinars and such like that. And they really threw me into the deep end, which I guess I asked for, actually, by putting me on the UFS, the dev branch. This was partially my NOAA advisor, which has been amazing, his Barry Baker, and he encouraged me to get onto the dev branch just straight out of the gate. And I was able to design experiments on there. If you guys came to my talk yesterday, you know, I built and designed my own sediment supply map for use within the Fengsha dust emission scheme, and was able to actually plug that in and get realistic AOD values out the other side, which is very exciting. This fellowship is also amazing in supporting me in publishing almost 3 papers. We've got a first paper that is published, one is in review, and there's a third one which will follow shortly. Like I said, this has been a wonderful opportunity. Like, could not have done it without what we've dubbed the flight crew of the Wings Fellowship. So doing a PhD is all fun and games, and it's science, and it's really cool, and you get to become a science officer in real life. But you also grow as a person, and I don't think I would have grown nearly as much as a person if it were not for the Wings Fellowship and the people that I met along the way. So huge, big thank you for that. And since we only have 3 minutes, I will share that my future plans are that I actually 2 hours ago got the postdoc official offer letter in my inbox. So I'm going to be moving down to the University of Maryland, which is not that far, so I don't actually need to move, but I'm going to change where my desk is and do a postdoc down there. So I'm going to continue in the Earth system modeling track and really continue to polish up developer skills. And yeah, I'm happy to talk about dust emission schemes anytime.
That's not me. That's you? You want to present my slides? All right, sorry about that. My name is Joey Nisley. I'm very thankful to be here. I'll just jump right in. First, I want to talk a little bit about my accomplishments in grad school and also since being a part of this fellowship, which I'm so incredibly thankful for. A lot of my work has been conducted on the HAVS model. I'm exploring bias correction techniques for satellite radiance DA, or satellite radiance bias correction, excuse me. Running a high-resolution basin-wide HAVS forecast and analysis, which is a lot more difficult than it sounds. And I'm also working on some ensemble DA and forecast methodologies. I've had the opportunity to incorporate these code developments for the HAVS model and commit them into community code repositories. And as well, I'm also exploring some idealized work where I examine and quantify the effects of model bias on observation bias correction systems, satellite radiances, etc. 1 paper published already, 3 more on the way, and I'm not quite as far along as Shreyas and Emily, but I will be defending soon. Again, I really want to express how thankful I am for this opportunity. First of all, just the application and proposal process itself is a great learning experience, but I really want to thank Wings for giving me the freedom to explore research topics that actually interest me. I didn't include any of this stuff on the slides, but I learned this term earlier this week. I don't know, it's called PhD leakage. It's like the idea that oftentimes people will go into a field that they're passionate about, get a PhD in a field that they're passionate about, but then either because they are not really able to explore topics that really interest them, they're forced to follow the funding. They don't make the connections that are necessary to advance their career, and they don't learn the skills necessary to make make a career out of research that you love, and as a result, they end up, leaving the field permanently. They go become software engineers or whatever. And no shame in that. Obviously, plenty of brilliant people do this, but I'm very thankful that Wings is giving me the opportunity and the skills and the network that will allow me to continue, all the research and continue all the stuff that really interests me. I've attended 3 of these conferences thus far, many other conferences, and presented my work. And like I said, I'm defending this upcoming semester, and I hope to, I will continue this career in NWP model and observation development and research. And that I really owe it all to the wonderful folks at the WPO office. So that's all I have, so thank you.
Okay, good afternoon all. So similar to Emily and Joey, I'd also like to begin by thanking NOAA Weather Program Office and UCAR CPAS for the Wings Fellowship. Right from the application process, it was a great experience drafting a proposal and various other application materials. And over the last 2 years, I would say that I've gained a lot professionally as well as for my PhD thesis as well. And a couple of days back, the results that I presented, I have analyzed forecast of the retrospective runs of the UFS and predictability of real-world case studies of weather events. And the work that I've done using the UFS model is a chapter in my PhD dissertation. And since I was always interested on operational research, I would say that Wings has given me a great opportunity to understand the world of numerical weather predictions better, and the research that is being done on operational NWP models has a direct impact on weather and climate forecast, ranging from short range to synoptic scale to subseasonal to seasonal scales. And overall, it has improved my understanding of numerical models and NWP, and I've kind of understood the challenges which are associated in developing newer versions of the models and various model evaluation metrics, what kind of data sets can be used for evaluating the model performances, and the best practices and methods that are used in this overall process. Also, a big thanks to Wings for a generous travel budget. I could have the opportunity to attend as well as present my research at various conferences, both national and international, starting with the AMS Conference on Hurricanes and Tropical Meteorology, the AGU General Meeting, as well as the World Meteorological Organization International Workshop on Monsoons. And also attending and presenting at the monthly coupled model tag-up meetings or the UFS S2S all hands monthly meetings, as well as UIFCW since the last 2 years has been very useful. Also getting an opportunity to present at EMC and visiting the EMC building was also very useful. And overall, from various seminars and talks and webinars that I've attended, it was a valuable learning experience understanding model performance evaluation for the continental US weather, as well as various oceanic parameters and ocean models, as well as air-sea interaction phenomena and the monsoons. Future plan is to pursue research in the field of tropical meteorology and numerical weather predictions, try to address the unknowns when it comes to prediction of tropical weather on a medium range scale, and help bridge the gap between theory and prediction. And in the last 2 years, I'm happy that I could publish a paper, and 2 more are in review, and a 4th one is in the writing process. So big thanks to NOAA, WPO, as well as UCAR for this wonderful opportunity. Thank you.
It's a little clicker thing. At the screen, okay. Okay, well, that's not my title slide. That's my title slide. Okay, excellent. Hi, I'm Elena. I'm new here. I'm a 6th-year PhD candidate at the University at Albany.
My advisors are Andrea Lopez-Lang at the University of Wisconsin-Madison, Zheng Wu at the University at Albany, and then my NOAA WPO advisor is Mark Olson. I've included the title here. I'm not going to be talking about, like, obviously this is a talk about what I'm going to be doing, what I'm going to be working on, rather than what I have done. So just be giving a kind of brief overview of the key focuses of my research, which is about subseasonal predictability and stratosphere-troposphere interactions. And also, huge thanks to UCAR, CPAS, and NOAA for the opportunity to participate in this fellowship. I'm extremely grateful and really looking forward to seeing how my research kind of progresses over this last year of my PhD. So quickly, because I thought I had 5 minutes, but I actually don't. As I said, my work focuses on subseasonal predictability and windows of opportunity, which if you're not familiar, when we're talking about windows of opportunity, what that's really talking about is looking at the teleconnections between various aspects of the broader atmospheric system. So climate modes of variability with Rossby waves, things of that kind. And they can be used in subseasonal predictions to extend predictability beyond the medium range. My research really focuses on anomalous stratospheric conditions and how those kind of modulate the tropospheric flow and create these preferential patterns that assist in informing predictions. And really, backwards instead of forwards, okay. My work focuses on the stratospheric polar vortex, which in the northern hemisphere wintertime is this strong band of winds in the stratosphere, which surrounds the North Pole. Those are modulated by changes to upward propagating Rossby wave activity. And within the stratosphere community, we really have a good understanding of upward interactions between the troposphere and the stratosphere. And my work really tries to hone in a little bit better on the specific downward wintertime interactions between the stratospheric polar vortex and various surface conditions. So it's already been established that various changes to the strength and location of the polar vortex kind of serve as this known source of predictability down into the troposphere, with certain research showing that specific conditions of the polar vortex can kind of produce this enhanced forecast skill for northern hemisphere temperature extremes. And I like to show this figure from a paper by Butler et al. In 2017, which kind of shows the statistically significant surface temperature anomalies in the 60 days following sudden stratospheric warming or SSW events. So really the core of my work is interested in evaluating this relationship a little bit further, establishing specific windows of opportunity forecasts for focusing on stratospheric polar vortex extremes and then connecting those downwards into the troposphere. And traditionally, a lot of people use zonal mean components to look at this, so things like geopotential height and wind. My work focuses more on whether or not we can apply non-zonal quantities to do so. So basically the way that we approach this is by using geometries to describe the non-zonal location, shape, and behavior of the vortex, and then using those as one-dimensional time series to apply them into forecasts as diagnostics. So the way that I do calculate these is by fitting a best fit ellipse to a certain contour of geopotential height in the stratosphere, defining the vortex edge, and then from that you take these geometries defining center latitude and longitude of the ellipse, its size, rotation angle, things of that kind. And then the idea is to apply those as inputs to a machine learning model or into a forecast, and then just kind of evaluating whether or not you're able to identify forecasts of opportunity using those as the quantities. And then I compare those also with the zonal quantities. So there's a lot of text on this slide, and I'm not going to read it. But pretty much it just gives an overview of my proposed research questions that I presented for the Wings Fellowship. And then if you have any specific questions about the methodologies that I plan to use, please just come talk to me. I'm happy to talk about it. So, and now Luke, yeah, he's online.
Hello, my name is, sorry. Oh, I'm not sharing. Okay, sorry. I'm also new here. My name is Caitlin Pereira. I am also a part of the 2025 Wings cohort. and a PhD candidate at the Colorado School of Mines. And I just wanted to start off by saying that I'm so sorry I can't be there in person today. I wish so badly that I could join face to face, but I actually just had a baby boy a few weeks ago, so I'm having to join in a virtual capacity today. But it's been a joy participating from afar and watching these brilliant talks. And I am so looking forward to being face to face next year. Thank you. I first want to thank you for the opportunity for this Wings Fellowship. I'm so excited for what I'm going to accomplish and the opportunities for what I'm going to accomplish in the next couple of years. And I thought I'd start off by talking about what I'm kind of looking forward to most as a Wings Fellow over the next couple of years. So what I'm really looking forward to is learning all that I can and implementing all of the different perspectives that I can to push my research forward, whether that be from my brilliant Wings fellows or the mentors that I'll have the opportunity to work with. And kind of along those same lines, I'm really looking forward to sharing my research at different conferences such as UIFCW25 and AMS, and just further collaborate and network. And I'm really excited to discover UCAR as an organization and kind of understand the inner workings, as it would be a dream to work there in the future. And of course, I am looking forward to finalizing my research and contributing to the field of weather modeling. And I think that's kind of just the perfect segue into kind of a very high level the purpose of my research. So specifically, I'm hoping to tune ocean-derived algorithms for large lakes, which impacts how we're representing physics and in turn, how accurate evaporation and turbulent heat fluxes are in our forecasts. And I'm really excited. I think this fellowship will allow me to see, or I know this fellowship will allow me to see this dissertation through and kind of gain feedback through my peers and mentors and allow me to share what I've learned in different conferences and ultimately improve weather prediction. Thank you.
Sorry, are the slides being run from that side, or should I share my screen?
We are sharing for you, so just let me know
Okay.
when to advance.
All right, sounds good. Okay. Yeah, so I'm Luke. I similarly apologize for not being there in person. I'm in Australia currently. So the timing of it would have been awkward if I had tried to stay in person. But I think I want to start by saying congrats to Kate, and that I definitely looked worse for the wear than you do several weeks after having my kid, and I wasn't the one who gave birth. So you're doing great. Congrats. Yeah, so I think we can go to the next slide. So I'm going to just start by going really quickly through satellite DA just to kind of motivate things. So we can go next. So we have a forecast, and we have a nice fancy satellite observation. That's great. We want to be able to update the forecast with the satellite observation, but the satellite data is kind of narrow band radiances on a 2D grid, and the forecast is this 3D numerical NWP grid. So they're not they're not the same space. So we can't do a direct update that way. So we can go next. So yeah, we can't do that. So the way that we generally do this is by using a forward or observation operator, which is often referred to as H of X in the DA space, where we're mapping from the forecast to the observation space. So we're saying what's the simulated observation we would expect to see if the forecast were perfect. We'll go next. And so now we have the simulated observation that's living in the same space as the actual observation, and we can do a direct comparison there. Wave hands, do math, update numerical weather prediction, initial conditions. So there's a lot, behind the wave hands, do math thing, but that's the focus of my research is on using machine learning to emulate that observation operator. Next. Yeah, so that ends up being a computational bottleneck just because of the volume of observations, which is the motivation for using machine learning. So okay, I think next is at the actual next slide now. Sorry. Okay, so plan research. So this is something I've already done. I built a machine learning emulator of the community radiative transfer model, which is a very commonly used satellite observation operator. It's probabilistic, so it predicts its own error. So that's currently in revision. The QR code goes to the preprint. And the next. So planning going forward with my Wings Fellowship to I want to retrain on a larger data set probably. There's some issues with the Jacobians, with the machine learning emulator. And ultimately, this is kind of in progress right now, is integrate the emulator into the UFO within the JEDI ecosystem so that we can run DA experiments, validate its use in kind of a more real-world operational setting. And then I think down the line, also, there's kind of an idea to build the decision logic with the error prediction into CRTM so that we can essentially revert to CRTM in conditions where the machine learning emulator is not as confident in its predictions. I'm very excited to continue. I've been doing this work in collaboration with JCSDA. Very excited to continue working with JCSDA on this, and really excited for the opportunity via the Wings Fellowship to work with, I know a mentor, Dan Holdaway at EMC, and other folks at EMC, as it makes sense to push this work forward and make it more kind of operationally useful for the community going forward, and build training pipelines, all of those good things. Yeah, and I also want to say that I was able to make the trip to Australia because of the Wings Fellowship and the funding for travel associated with it. So very grateful for that as well. I think that is all I have.
I would like everybody to give our Wings Fellows another round of applause. Not only did they keep on time, they actually left 5 minutes for questions if anybody wants to ask them a question, but please give them a round of applause. Anybody? Yeah.
A question for Caitlin. And in her first slide, she showed, I think.
Can you use the microphones that we have?
So, Caitlin, you had a first slide, and I think you showed an internship, maybe with U.S. Navy Meteorology Oceanography Command, and I wanted to see how that experience helped shape your exposure to the METOC community and give you ideas or networks to follow on and build upon with your Wings Fellowship. Over.
I'm not sure if that was me, but I did have, I got introduced to this work through, I don't know if it was an internship, it was more just, I was a researcher for the UFS coupling on the FVCOM side. And that was what really made me deep dive into numerical weather prediction. And that is what inspired my dissertation ideas. Am I the right person? I'm not sure.
Oh, I don't know, like, if you could show her first slide, I'm not sure, but where that was taken then. Yeah. There on the left.
Oh, that was just, so I'm using spotter buoys for my research. And so I didn't actually, I was just taking a picture in front of a spotter buoy. That's not actually, I'm not part of that. That was at AMS last year. And so that was my first spotter buoy that I'm using, but I never actually been with one. So
That was our booth then.
sorry.
Well, with that, if there's no other questions, I do want to say congratulations to our 3 fellows. That's very close to defending. I think it's Srias, Emily, and then Joey in that order that's defending. So congratulations to you. And we really hope this is setting you up for success, getting your next position or postdoc. And welcome again to our brand new 3 Wings Fellows. And thanks, everybody.
All right, so now we are going to go straight into our interactive session, which will be, it's new this year. We wanted to get a little more engagement and feedback from you guys and kind of do a little bit of brainstorming things that I hope we have fun with. So we've got candy, we've got activities. It's gonna be a great time. I can click. I'm a clicker. Okay. All right. Here's what we're gonna do. So first, we have some questions that you are going to discuss with 1 or 2 or 3 people near you. And then we're going to have a short readout and get some feedback. So maybe we'll take these mics down and kind of walk around. And then we have an activity that's going to involve you standing up called the Stoplight Hustle. And that'll be kind of a brainstorming session of how we can engage more. Then we're going to have a brainstorming session where we're going to have 4 questions, and you're going to go to your favorite question and do a little brainstorming with everyone. And then we're going to have a partner rebrief. So since this is like an interactive session, feel free to like get up and like go get some more coffee if you want to like, I want this to be flowy and fun. So get some candy, get some coffee, and let's do this. Okay, so with the person nearest to you, or, go find somebody else you haven't talked to very much, we have these 3 questions. Rowan has a question for me, maybe? Sure, if you wherever. So just have a chat about these things, and then after 10 minutes, we will see who has a share of some of these ideas. Ask me if you have questions about them, but they're pretty self-explanatory questions. Woo. Yeah. Yeah, so just anyone needs sugar so you can talk with your partner. Sugar. I can run a timer too if that's. Yeah. The guy who was helping me set up a class thing from like it's just like
No, was that the AMS?
that at school.
Yeah.
You guys, brilliant. You came up with brilliant solutions.
I'll share it.
I heard a good answer. Did you? I'm curious if they're.
All right, your time is up for discussion. It's time to, I don't know, read out your
Okay.
results.
Class, settle down. And we're
I'm gonna go to the front of the room now.
we're gonna do a readout. So, will you do 5 minutes for me? So I would like not to go in any order, but if anyone just has any ideas of any of these 3 questions that they want to share. Yes, bring that one around.
Hi, so I'm a professor at a university, and so we had some comment. Like, I felt like this week we got a really good idea how certain NOAA labs work really well together with NCAR, like the main players. I, as a university person, did not feel like much of a part of the community, and several of us pointed out, if you're at smaller schools, you might be the only one using the WRF or MPAS. And the help, we vitally then need the help resources to be able to be a part of the community. But we were commenting, like, WRF help for years. You can submit a request, I need help on this, and 15 days or more goes by, and you know, with a younger person, it's hopeless, and you're stuck there doing nothing for 15 days. I'm older, and so what I would end up doing, my students aren't hearing back, I would think of colleagues I've known for 20 or 30 years, reach out directly by email. Sorry to bother you, but I know you've used WRF. We're not getting any help from WRF help. Do you know what's going wrong? So I think for community engagement, there has to be much better job done of making it easier on all of us who are not at a NOAA lab, not at NCAR, to be able to get help past the hurdles that come up.
Nice, thank you. Kevin, I'm gonna throw you under the bus.
I love to be under the bus. Okay. I did say one question that I just thought was interesting is number 2, not saying the others weren't, but what does equitable contribution in the modeling community look like to you? I thought that was just a really good question because there's a lot of, when you have operations heavily supporting something, research heavily supporting something, how do you all coexist and how does everyone contribute at a reasonable capacity? So for the, what it looks like to me, it's just lots of communications and conversations about, who can support what at what percentage so that all the work is covered. But it really is just, I think the important piece is just really ongoing collaboration is part of the key to that, and it really is, more importantly, just a really interesting question to kind of make sure we keep talking about, because equitable contribution is important in a community modeling system. So yeah, so great question, and something that I think is the biggest takeaway that I had was that we were talking about was just important to keep talking about it for those advances. So that's all I have. Thanks.
So just kind of adding on to Kevin's point there, just a quick comment. Kind of what we wordsmithed here, it may be less equitable contribution and more so equitable opportunity.
Anyone else?
I'll just say again, glad you said that, because we were debating that too, like what exactly is that question meaning? And we said, obviously it can't be an equitable contribution. Places that have a much better access to big supercomputers will end up doing more of the work. But I said, but what it should be is that all of us can be contributing. And that's the thing that is challenging based on what I said before, when you are an outsider and you can't really get the help you need.
Nice, yeah, and I think from a social science perspective, we always talk about this thing, the difference between equality and equity, and there is, equality is everything is the same for all of us, and equity is the people who have the more capability do a heavier lift. So that is different terminology and something to think about for sure. Time? Okay, 1 minute.
Hi, I'm Natalie from EPIC. So we just shared some views with somebody from the outside of EPIC, and I was happy to see that we have the same perspective, that Community engagement means, first of all, that those who are in charge of delivering the products or make it community friendly do invest efforts to make it community friendly, and not see it as a possible options. Okay, if you have time, we have resources, we can make it community friendly, but we don't really have resources. So we just make it NOAA, focus on NOAA developers. So, so those who are in charge of the products need to make sure that some efforts is spent to make it indeed community friendly in order to get the feedback later, because otherwise it's very short-sighted, I think.
Okay, great. Thanks, everyone. Are there people online? Do we know? I don't want to be ignoring them. If you're online, you can answer these questions and we will add them, but also don't feel obligated if you're online and feel weird not participating. Okay, now this might be hard for the online people, but they can definitely still contribute as well. Oh, our Post-it notes. We need the Post-it notes from Jessica, but I'll explain this. Okay, so now what we're gonna do is, oh, and the stars, Jen, the stars, thank you. So we're gonna have some Post-it notes, and what I want you to do is, if you have an idea of how we can encourage community engagement that you think is really easy, put them on the chairs on this side. And if you have an idea that you think is somewhat difficult, but maybe we're already doing it, or it could be an easy thing to start, put it on these middle chairs. And if you think it's hard, it's just like a pie in the sky idea that would be so cool if we figured it out, put it on those chairs. And why it's called a hustle is because you're going to read other people's Post-it notes, and if you like them, you're gonna give them a star. It's like a one-up. And if you think that somebody put an idea as easy, but you actually think it's hard, just pick up their Post-it note and move it. And here come the Post-it notes. So, any questions? Green, yellow, red, yes. But the colors don't matter of the Post-it notes. Just like in a hard, medium, easy kind of color coding. All right, have at it. 15 minutes to hustle. Just give the stars out. The colors don't matter for the stars. It's just if you think somebody has a good idea, you can star their idea. Both. I mean, you can talk to your neighbor, but if you have like 6 ideas, just go for it. Maybe I should write some. Do you want some Post-it notes? Do you have ideas?
I do have ideas.
Kelvin, can we get a do the hustle music? Kelvin, you have a do the hustle music? Keep that up.
I know, I'm bad. You just have one at
every little spot, every location. Just
like,
random pens.
Like the waters in science.
That's medium.
Oh, I just gave the same color. It didn't matter what color.
The color doesn't matter.
Oh, where'd it go? Stop it.
I think you should get up on here and do your stuff.
Okay, that's fine. We just do regular music.
Because there's a lot of do the hustle on YouTube. I'm not sure if it's exactly.
It might get weird.
It might get weird. That's a good one. Let me go back to the.
Yeah, we can go back to our thing. Thank you.
Easy is all the way on the left. So it's easy, medium, hard, color doesn't matter, placement does matter.
One in the medium, I think. One in the
That's for voting. Could also bring stars.
Oh, I guess I'll wait. I thought
Use
it was
the
something
voting.
up there.
Once you share your own post-it, remember to upvote the post-its of others you think are great with the stars we've given out to everyone, I think, at this point. Have 5 minutes left.
2 minutes. Everybody's doing a great job. Keep hustling.
Thanks for tuning in. And I'm like, that could be modern slang for city leader.
We have 30 seconds left, so finish your thoughts and your stars.
Okay, everybody wrap up your stickins. And then we're going to have a little mini readout. Oh, hot stuff. Like that it's devolving into chaos.
Oh, if you want to hear us, they're about done. I won't get any stars.
Okay, now I am going to read out our one from each section that has the most stars. So get your last stars in. Should I start it easy or hard? Let's start it easy. Okay, yeah. Yeah. Thanks. Zach and I say thanks. Okay, let's see. So it looks like we have 2 winners on the easy side. One is NOAA Academia regular meetings to discuss innovation. Love it. Lots of stars. The other one is UIFCW. Okay, over here our winners are, ooh, I don't know. There's like a lot. This one has a lot. Okay, 8? Okay. Clear entry points in UFS code to enable research and reduce code complexity. This one? Oh, guys. Keep NOAA OAR. That one? Create cohorts of researchers and model developers to co-develop answers to answers/solutions to operational model challenges. Great. All right. What's hard? You want that one? There's so many stars.
Yeah, that's why I was picking the ones with a lot of stars.
Yeah, that's what we should do. I'm just impressed. Right. Make it easier to run the operational branch of models on non-NOAA machines. Kevin says yay. I don't want to say the G word. UFS governance. And then find a solution to allow non-funded to contribute to operations. I like that one. Okay, thank you all. That was really fun. Do you think we should hustle next year?
Yes.
How many stars are on the UFS song? All right, we'll think about it. We will think about it. Wait, only if we have time at the end. We're not ready. No. Okay, we didn't update these slides yet. I thought they were updated, but they didn't get updated. So 4 and 5 are going to be the same question. You're going to go to the same place for 4 and 5. Okay, so we have 4 questions, and you're going to go to the question that you find to be the most interesting. So number 1 is going to be the new AMS modeling committee. Will be in that corner over there if you want to talk about that. Number 2 will be UIFCW if you want to talk about that. And Will, you're our liaison for that corner. I will be over in this corner for the community modeling committee. In the back, your left, we will do how can you better participate in working groups and the cross-cutting teams? How can people or you, or between working groups? And then the last one, we couldn't figure out the wording, so it's both of these questions, but barriers to entry for UFS and ease the use of it would be in that corner. So find the question that's most interesting to you. Bring your pens. Jessica was supposed to give us like big markers, but yeah, she was nice. Yeah. And then I think we will switch. If you want to do more than one question, we will switch, and I'll just let you know. So go to the one you like best. And if one's lacking, help somebody out. Hustle. Community modeling committee, that corner. UIFCW, that corner. Barriers over there. Working groups over there. Yeah, sure. That's cool. We're ready for music, Calvin. Community modeling board is that corner. Yeah, and I don't. Yeah, okay, this is what I wrote. Okay, is everyone feeling wrapped up? Do you want to rotate to another question? You can feel free to just like go around, or if you want to go to one you like best again, whatever, just follow your heart.
back left corner, if you could rotate to a new question. Or not, it's entirely up to you. This activity is voluntary.
Give me some eyes if it looks like we should switch to another question. If anyone is still listening online, feel free to write your responses in the chat or just email me. I don't want to feel like you're left out. I know there's a few people still online.
All right, I think it's about time for everyone to switch questions. There is still a question in the corner with the shrubbery, if anyone would like to take that one up.
Okay, we are rotating one more time. Pick your next favorite. It's just us.
Oh, okay. I was thinking like. Because you had like, was it sidebar? People were having sidebar rooms. Yeah, sure. Had
Maybe separately. Ken and I leave the.
Sign up for them or something. Get all like. Yeah.
Yeah, she seemed like a chick.
You got a short period of time.
us for the first, like,
Sure. Facilities. The idea is that, for example, either you or your advisor request that it's not even installing because it's a container, you just need to know.
and the people who are leading it are not.
I understand that even for some system admins, it's right, because they don't understand the model, and then like different layers of that. One is at the system level that you need to enable some kind of basic so that the system. Then
You guys got all the ideas? Write everything down? It's looking great.
It would be hard to manage if it got bigger, but that would be one way to reach out. But I think that just comes That's true. It could be more virtual participants though too. 1,300 total. I don't think it was that much. I thought it was like 500. Probably some people didn't even register. Yeah, right. Other stuff. Give certificates. Yeah. Right. Yeah, exactly. Right. No, I think that's good. That's a good point. Now we're taking it to the whole new level. Yeah.
Like how like in AGU, like there are so many awards given. Like this is give awards to anyone, like.
Okay, great. Okay, we are going to have our final readout and then wrap it up. Thank you all for being so participatory, and I hope you guys enjoyed yourselves, got a little walk. Let's see, where should we start? Everybody left. Jen? Oh, you're over there now. I'll read out this one. Okay, so for the new AMS Community Modeling Committee, what we have concluded that we want to focus, what's the question? What should be top priorities and challenges to address? We said student representatives, partnering with universities, better and more tutorials, the whole community, also the united community, governance ×2, boo. Systematic approach for modeling development, I like that one. Standardized coding, agency agnostic, fun. Knowledge transfer and management. Great. And then, also data assimilation engagement is written really largely, along with workforce development. Great. Thank you guys for that. Will, you left your post, UIFCW, will you read out? I mean, I could read all of them, but I've been talking for a while.
Okay, I'm not out of my responsibility yet. Okay, so for UIFCW 2026, we had quite a few suggestions. First was do a collaboration session earlier and then also again later in the meeting, because that gets everyone up and moving around and those sort of things. And with the keynote speaker to encourage attendance all the way through the end of the meeting. There was some questions about when's the best time to do the meeting, whether it's July versus September. So one suggestion was have it at the end of the summer, but before classes begin. So this is really threading a needle, but maybe like mid to late August. And also there was some concern about it. If it's too early, it overlaps with internships as well. So, but there's never going to be a perfect week for everybody. Also, the location alternating between the East Coast, West Coast, and center of the country was suggested. I think 5 days was generally considered to be a good length for the meeting, especially if it includes training sessions. Sunday training before the conference, kind of like AMS does these days, is one possibility. More interactive components and group activities like this. Longer in-person training sessions was another suggestion. One that was very popular was the job board or announcements, like for upcoming positions, even if they're not posted yet. An international session about how the international community could benefit the UFS. Programmatic and high-level talks all being on either the first or last day, because a few people did tell me that they're not as interested in those talks. Advertising the meeting more widely and with new users, even if this means people who can only attend virtually. Apparently some students still haven't heard about it, so maybe there's some mailing lists that we could reach out to. And the final two, attendance certificates to help engage students, and also maybe some awards for participation, or whoever got the most questions, or whoever got the most people at their poster or something like that. So yeah, a lot of good suggestions here.
So we probably collected the most responses. Understandably, we did have 2 questions, and they are loaded. So I'm going to quickly go over these. I might skip a couple that sound kind of similar. Okay, so first of all, easy access to HPC. We also said in another place in here that we want a community computer sandbox supported by the EPIC team. So both kind of similar, HPC more on a individual disconnected, and the sandbox is a collaboration. Be able to run the UFS compatible to your own use case. Resolve compiler issue for non-NOAA, even with container, they feel like they would need a workaround. Create canned cases without workflow. Did I get that right? All right. More user support, topic-specific user prompts, a summer school for underrepresented developers and users, an online course series with Q&A sessions, a community computer / sandbox, oh, I already said that one, online tutorial with sections for compiling, running, and post-processing, current turnkey cases, and we have some eight things that we all want. We need to get rid of turf, ego, ignorance, arrogance, business as usual, only my budget, silos, stereotypes, nickel and diming funding. And we need more engagement with universities, encourage UFS use. We need to incentivize that. Roadshow, let's actually do it. Next, clear and easy pathways for collaboration and integration, model comparison test beds, and standardized metrics. Synergy between agencies, academia, nationally and internationally, with WMO programs, U.S. agencies, universities, and industry. Make an accessible version of the UFS applications to run on community available resources, Linux clusters, Mac platforms, standard cloud systems. Make it a priority in all caps. Code complexity. Increase the ease of use of development entry points to the research community. I am done. Is that it?
All right. Mine was the least popular, so it won't take that long. It was the working group question. The biggest thing, what takeaway was transparency of what groups there even is, what they're working on, and how to join them. And someone suggested an interagency group, such as something under ICAMS, perhaps, or under the AMS umbrella. And let's see, inclusivity, open access to academia, industry. So how do you, being able to join even if you're not directly working on an application. And like consistent leadership of these groups, rotating on and off. That's pretty much, yeah, that was pretty much it.
You forgot professional facilitators?
Well, I don't know what they'd be facilitating.
Like the working groups working together more effective. I don't know. They would facilitate something.
Okay.
I'll think on it.
All
Okay.
right.
Does anyone else have anything they want to add that they talked about that we didn't cover on this little part? New? Okay. All right. Last thing. I'm not going to make you guys read out for this one. I've got 2 microphones. This is just, chat amongst yourselves, and you guys don't have to tell me about it, so be honest. Yeah.
Or you have like 10, 12 minutes to just chat amongst yourselves.
You can go get coffee and stuff. Just come back for
Or
the
get more
3:30.
candy.
Oh, unless you want to do. Rowan has a readout, so no, you should do it. Okay, everyone chat amongst yourself for 7 minutes about these questions, and then Rowan's going to summarize everything that we covered this last hour.
Hi, Dad. Oh, my dad, who is, I think, watching.
Rowan's dad's watching. We're just saying hi. Rowan was a great intern. We love her. Okay. We're also. Okay, now Rowan has been taking notes while we've all been doing this, so she's gonna give us a few of her thoughts of how she thought the session went and some like the greatest takeaways, and then we'll go to the big conference debrief.
All right, yeah, I think there was a lot of great discussion. I'm glad that we had people up and moving around and talking. I think the biggest takeaway was to expand kind of the circle of what we consider the UFS community beyond NOAA users, and not just say we're doing that, but actually make sure that non-NOAA users have access to the models, to HPCs. A big part of that, like I mentioned, is compute access. A big part of that as well is communication with the academic sphere. Additionally, creating standard practices for development and contribution so people, know where to start, know how to become an active and contributing member of the UFS community. Additionally, there was a lot of input on the UIFCW schedule. Okay, now we're good. Okay, on the UIFCW schedule to make sure that we have equal attendance between the days, to maybe not make us be here on Friday. I'm happy to be here on Friday. It's beautiful in
Having
Boulder.
a great time.
But there was some input on the scheduling, and then there was also, I noticed, a lot of emphasis on data assimilation. There's some big data assimilation fans in the room, who I think is John Ising right there. Did anyone have any thoughts that I missed? Any big topics that didn't come up in that summary?
Great. The only other thing I would add is this is the first time we did a thing like this. So if you thought this was cool and useful, if you could write that in your post survey so we can ensure that we do it again, or if you never want to do this again, write that as well, because we're trying new things. So we want to see how you like it. And that's, Jen wants to add something.
So if we were to do a session like this again, what day of the week would you like it on? We do it. We can't do it first thing if it's like a recap of the week. Midway through the conference? To get more participation? Yay? No? What day? Yes, Thursday because of the parallel sessions. Maybe do it on the day we have the poster session because it brings a lot more people in.
Okay, I will add something that when I was planning this activity, I involved ChatGPT and I said, how do I do a focus group for 150 people? And it literally said, don't do that. It said, there is no way that an effective focus group can be done with that number of people. So just in terms of what kind of goals we want out of this session, I kind of like that it was small, but if we do want to make it bigger, we should think about what, yeah, it'll get ChatGPT no like. Yes, go for it.
I did just want to mention that the website stayed up the entire time this year.
Woo. Any other thoughts? If not, we will go to our esteemed closing team. Are you John Tenhove now? I mean, technically she has 2 minutes. Oh, why did no one talk about the UFS song as one of the activities that we wanted? Hendrik? We have 1 minute. Yeah.
Who of you were around? So who of you were around last year? There was a Lion Sleeps Tonight version of the UFS. So this year, in terms of equity and stuff like that, who of you knows what the top #1 Billboard song was in 1955? That was Tennessee Ernie Ford with his rendition of Merle Travis's song 16 Tons. So that's an easy one to transfer to to a potential UFS song. I just worked on that a little this morning, and I need my own cheat sheet. So you guys know how that song goes? Goes something like, so you have to imagine this is the simplest song ever, because there's a guy who's just snapping his fingers on a fixed rhythm. There's just one clarinet and the guy singing bass, and the original song goes something like, you load 16 tons, what do you get? Another day older and deeper in debt. Saint Peter, don't you call me, 'cause I can't go. I owe my soul to the company store. So if you transpose that to the UFS, it goes something like this. You've got 16 bytes, what do you get? Another run over and no results yet. Fifth compiler, don't you tease me, 'cause I don't know how to get this model run go. So we're starting on that. We'll see the full version next year. Yes, I am definitely definitely an introvert, and I don't like to speak in public.
So we are entering our last session of the workshop, and thank you for those of you who stay with us up to this point. So we have a panel put together. Here we have Kevin Blackman, Kevin Garrett, Rowan Smith, and Shusha Jan. Here they represent different sectors. So I think we have a very good panel here. And myself, I have some closing thoughts, but I want to pass the floor to each of them so that they can speak to their takeaways from this workshop. So we can start from Kevin Blackman. Either way.
All right, hey, how's everybody doing? So I'll be pretty brief here. I just wanted to share a few things. So, it's been a great conference. Really appreciate all the help from our collaborators, because it's not just Epic. There's tons of collaborators that make this possible. And she's been sitting out there the entire time. So one of the organizers is Jessica, and she's never in here to do this. So just if we can give a round of applause, just like last year for Jessica. Much appreciated. So, yep, thank you very much. And then finally, I just wanted to say that just kind of looking at some of the numbers, we had 1,300 people, both in person and virtually, attend throughout the course of the week. So that was phenomenal. So thank you to all the staff here at NCAR that also made this possible. And finally, we also had 454 participants in workshops. That's by far a record, so that's pretty awesome. And it just made me reflect for a minute. If we look back just a few years, our first workshop on Epic, we had 25 people. So now seeing the numbers clip 200, it's pretty amazing, and it's awesome to see all the great kind of innovation going on throughout the community. And I just, as always, I look forward to what this conference will look like next year. It's this great size of just seeing all these innovative ideas, and just love walking around seeing all the different posters on what people are doing. And it's just, it's really become a great event, and it wouldn't be that way without all of you. So I really, really appreciate it. And then in closing, I just want to say I really look forward to UIFCW, and if I could just do one plug, it would be to, all the kudos that we read throughout the kind of after action email that goes out are great, but it's really like the honest feedback. Hey, like we should change X, Y, and Z that makes this better for next year. So please give us candid feedback. Let us know what worked. Let us know what didn't work, and so we can continue to make this a great event. So My flight is delayed by an hour and a half, so I'm good now. So, but I will keep this short just for everybody else. So thank you very much, and I'll pass it back to Maui. Thank you.
Thank you, Kevin. So we will just follow the order where you sit, right? So Shushar, go ahead.
Oh, I'm sorry. Oh, this one? Oh, I'm sorry. I'm so pleased and be part of this conference. And basically, in the past 6 years, I've been working in the industry, private sector, but for the weather application part. So this time, my big, what they call the takeaway from the industry sector application perspective, I have 3 major, I think, will create big impact, I believe. Number one is the high resolution real analysis product. And so basically, either for the hot topic of whether AI research or WOLF FS, the short-term, what they call the short-term weather forecasting application perspective. And so the industry need those kind of data for variety applications. Another work, I believe, is very important led by the, this group of people is the CICD framework for UIFCW system that help industry, enhance the best product, what they call the practice in terms update software framework and make life lots easier. And another piece of this will containerize the UFS product, or from application perspective, make the software maintenance much easier. As myself, I have ported the UFS or GFS model for both deterministic modeling and also ensemble model. So I experienced the challenge with the version of libraries, version layer compilers, and the version of the software update, etc. Which is very challenging. But with the containerization and also CI/CD, and these procedures can be, lots of smooth use and reduce the labor cost, really increase the productivity of adopting wonderful weather research work here. So basically, that's my takeaway.
Thank you, Kevin.
Sorry to be the long-winded one. So if you have a flight to catch, now's your chance. But you might be able to use this recording as your BAMS article to summarize the workshop. No, I'll try and be quick. Actually ran out of time trying to scratch out some of the key takeaways, so that'll save some time. But regardless, I did capture a few different themes, I think, and takeaways from the workshop. Unfortunately, I think beyond the plenaries, some of the breakouts, I couldn't be everywhere at the same time, so definitely some gaps here. But I guess one of the themes is really that we talked a lot about throughout the week was on research to operations transitions, not just the accomplishments, and also not just sort of what's hopefully planned to be implemented in the Weather Service for the next year or two, but the process itself. And I think everyone is striving for accelerating the RTO pipeline, realizing that there are tremendous challenges and overcoming obstacles to move stuff through that pipeline into operations. A lot of it for good reason, and so there's from at least my perspective, some concerns on how effective we can be at developing strategies and new processes to really accelerate. Of course, there are things that do take a long time. I think that maybe there's a lot of room for improvement. So some things that were mentioned were, really sort of trying to involve the operations folks in the development process. I think Jacob coined it as baking that stuff in up front in the development and the research. But, researchers, that's a lot of extra overhead that maybe is not going to improve their research outcomes that they would have to take on. So we've got to find the right balance of, when's the right entry point when that research is being done to then start thinking about, implementing sort of the best coding practices and operational hardening and things. Because I completely recognize that, all of that stuff falls on EMC, and it takes a tremendous effort to do that for every implementation, or even just integrating new capabilities one after the other, and sometimes duplicating efforts. If their changes haven't made it back into the authoritative repository, so that's definitely a concern that I think is worth trying to focus on and figure out what works best. Testing and evaluation, that's another piece that's pretty exhaustive. Obviously, we want to implement applications that provide our forecasters guidance they can trust. They understand the errors. And so if we don't have well-defined metrics, we don't get those prototype data in front of forecasters to get their feedback, to get them comfortable with it, to train them. That's it's going to affect how well they're able to do their job. So again, I think there are probably ways that we can change the development life cycle, including the T&E aspects, to try and accelerate. But again, how much can we actually accelerate to ensure that we're providing the best forecast guidance data that we can. And then there was obviously some mentions of CI/CD. How much can that sort of those approaches help with the process across that value chain? And again, training developers on whatever process is established as we bring people into the UFS community, making sure they understand sort of that end-to-end process to get something into operations is going to be really, really important. Community engagement was another theme. I think it was Rowan that mentioned sort of the need for more student engagement, and even more broadly, academic engagement in general. So I think you've done a tremendous job in kind of highlighting and trying to come up with ideas with the short-range weather and use cases and say, hey, here's like a package with a some issue that we're having with a type of weather phenomena or environmental phenomena. You can build this package easily and then start running it and figure out maybe some innovation to tackle that challenge, and maybe it's a solution that's able to improve forecasts that are representative of that issue. So I think doing more of that and reducing those barriers to get folks into the UFS community are going to go a long way, especially in academia. There are also possibilities for like other incentive structures. We have limited resources and limited funding. So the UFS community, still I think by and large are folks that we're funding through grants and other vehicles to work on the UFS. Maybe there are some smaller, more affordable incentive structures to get people at least getting them to use the UFS, and then maybe once they're in the community, they find it's a really valuable tool and they can apply it to other research at a minimum and contribute development in the long run. So, and then just general barriers, are always a challenge as well in terms of the HPC resources, very complex system. Just being able to build it. I've never tried to build it, so I really can't speak from experience. The last time I tried to build an NWP system, I'm not going to mention, but it was actually pretty easy, but it was a lot less complicated. So maybe I should try that when I get back to Maryland. So just kind of like simplifying that process. There was a lot of work or comments today about just Backstack and trying to build that, and if people need to spend more than like a day on it, they're going to abandon it. So that's that's just not acceptable, I don't think. So I think the ad hoc community modeling committee, that's being stood up, that, and this is, we're finally starting to roll out this governance. That's just the first step, but an important one in terms of understanding community needs for the UFS, not just the support, but also, just the different tools and infrastructure that they would like to see incorporated so that they'll actually use it. It's going to be important for us to understand. So I think I had one more, sorry. This is a short one though, looking forward. It should be probably the longest one. So I was really impressed with a lot of the AI talks that were here. I was trying to recall what was discussed last year in that space. I don't think it was nearly to the level that it was this year, and there's just been so much progress that's been made. It's of course, obviously a fast-paced, fast-moving area, and there's so much opportunity, but it's great to see the work that's being done in the UFS side in terms of developing new emulators, developing a framework through Anemoy, and trying to get that out to the community to do innovation in that space. There's a lot of work still to do in terms of getting better training data, getting testing and evaluation pipelines, actually defining metrics that are important, and those sorts of things. I did note there seemed to be some parallel efforts in terms of the testing and evaluation. We've got stuff going at DTC, we've got stuff going on at GSL, even the private sector and NVIDIA. David Hall was mentioning some things that they're doing. So I think there's an opportunity to kind of align those efforts, and they're all trying to, I think, address the same concerns and evaluating these new models. Maybe it's good to have some diversity in those things, but I think we should explore how we align and make sure that when we're doing these evaluations that they're following certain standards and metrics. So I think there are other things looking forward, but in terms of the governance, but I'll stop there. Thank you.
Thanks, Kevin. Go ahead.
I actually had a slide in the slide deck. If you go, I think it should be the last one.
Let me see. Okay. Do you want
Not
me-
that one.
Okay.
Well, unless I could read off of those if you want, but
This one, right?
that's this one. So my big takeaway from this conference, after talking to both fellow students, professors, people in academia more generally, is that the UFS is not currently reaching academia in the way that it could. And I think this is a major issue because reaching students in academia isn't just like something nice to have for a community-based model, it's a necessary condition to having a modeling community. If you're not involving academia and you're just having people with access to NOAA systems using the UFS, that's not a community model, that's just another NOAA model. I do think that there are some pretty shared agreements on the barriers to accessibility, being the setup requirements for the UFS and the processing power requirements. And I think these issues can kind of solve each other. If you make the setup easier, people will be able to find processing power, whether that's on university clusters, on cloud, or any other source. And if you give people access to processing power, then it'll make, obviously, setup not as required if you give them access to systems with the model already running on them. And I guess my big takeaway is that as we go forward, accessibility by outside users and by academia shouldn't just be something that would be nice to have, shouldn't be something that we're working towards, but should be a primary goal of UFS development. Yeah.
Thank you so much, Rowan. So before I go to my slides, I'm sorry, I'm going to keep you for a few more minutes to begin with. But I want to respond to Rowan that I feel bad that we didn't do a good job in communication, because one of the primary activity under EPIC program is actually to make the model accessible. So we just need to do a better job. And you are actually one of our hopes to do that job better. So before I let you go, I'll show wait, how do I show my slides? End of the slide. Yeah, I need to go to the first one. Yeah, this one. Yeah, so I just want to circle back to the beginning of the workshop where I mentioned a few desired epic outcomes. One is to build a community, another is to enable an infrastructure to enable a publicly accessible end-to-end testing and development environment. So apparently we didn't do a good job in communicating that. And also then bringing innovation. So I just had some reflections after the workshop. So actually in this workshop, this is the first time that we had a pig into the UFS community. Thanks for our social scientists work, because when I got into this job 4 years ago, I was like, okay, I was hired as a physical scientist. I don't care about social science. But then I realized later that I need to understand social science. So thank you so much, Alison, for that. So the two of them, Hannah and Alison, made a lot of recommendations on how to expand the community, how to better connect the community, and how to better strengthen the community. So we are going to look into that report and think about how we better do these things better. So the second point is that there are a lot of exciting progress made in the community infrastructure, including the containerization of UFS for research and for applications. We need to make sure that we have a better way to deliver that to our users, as well as to provide tutorials to users. And then we'll also see a growing co-developmental model and applications across the community, and the recognition from both the operational side and from the academia and from the industry that we need to shift to a new paradigm, which is DevSecOps, so that we can work more closely together. And also an explosion of AI tools and the need to realign our workforce. So this comes with challenges and opportunities. So how do we seek balance between physical and data-driven science and technology? So there needs to be some very, very serious thoughts underneath those questions. And innovations, while I was seeking a meaning for Epic, and because I got my NOAA colleagues coming to me saying, okay, well, I don't know whether we even have any users for SRW app that Epic has been supporting for a while. I ran into a poster just outside the lobby saying, okay, we actually now, a private company is running the community fire behavior model in the SRW app, and they're actually using it for local fire emergency management. So I was like, okay, now I find my meaning. So there might be other examples there that we need to think about this, right? So this is not operation within NOAA, but we enabled this operation in some way. And actually today we heard a lot of things about commercial weather observations. I would think it's commercial Earth system observations. So we need to think about how to establish evaluation platforms and pathways into operations. Not necessarily NOAA, but we need to be on the same page. And also redefine the public and private relationship. The last thing I want to note here is that just because of all these rapid changes, as Kevin noted earlier, shall we think about innovation in Earth system modeling curriculum in the academia? So that's something we all need to think about in my mind. So that is my last slide, and thank you so much for staying with us for the entire week, and I hope you enjoyed the workshop, and we'll see you in 2026.
As a final note, I'd just like to thank the tech team who has made this event run smoothly, whether it's through the presentations or the website. Thank you all so much.